Hello everyone, welcome to Automation Community. In this video, we are going to see about what is automation. Before going to the topic, please like and subscribe our channel. Let's enter into the topic. So what is automation? So there is no need of explanation, right? Even a kid know what is automation nowadays, because in our home we are using more automated devices. Example, you can say induction stove and automatic washing machine. Like that we can find more devices around us, right? Fine. So in simple, what we can call as automation? It is a self-dictated system. You can see the word automation gives the meaning self-dictating or a mechanism moved by itself. Move by itself or operating according to the program we have done, right? So the auto and matos means, auto means a self and a matos means moving. It is a Greek word and they have combined these two to make the word called automation. So why we have introduced automation? Mainly to replace the human operators and to improve the safety and obviously to increase the production, right? So let's move on to the history of automation. So automation was highly popularized in 1910s and 1920s. So there was a huge need of automated devices in the World War time. So that's the requirement of automation was more than those time. So that's what it was introduced and it was used widely in that era. And you can see in collaboration with the General Motors, automation department was introduced in 1947. And the PLC, the first PLC, before it was calling as PLC, it was called as 084, and we are going to see about this PLC and the usage in the later classes. But whenever it comes to automation, a PLC is playing a vital role, which is called as programmable logic controller. So we'll see more about PLC in our later classes. And let's move on to the types of automation. So as I have already discussed about the devices, what and all we are used in home will come under a home automation. And the second one is building automation, like the automation we have introduced in the building, like elevators, lift and all. And we have a industrial automation and process automation, public transport automation, where you can find the example like traffic light control. These and all come under a public transport automation. And the last one is scientific automation. Obviously for all our research and development we are using automated kits, right? So let's move on to the benefits of industrial automation. So why we are going to study about this industrial automation? Because the main invention of automation is for the industry, right? Because the production, we want to increase the production, right? So industries are our backbone. So obviously you can find more automation usage in the industry. And in our course, we are going to study more about this industrial automation. And here and there we will find some examples for home automation and building automation. So what is industrial automation? So the device or the system which we are going to implement in the industry to increase production, to ensure the safety and to replace the human operators. And as we have already discussed, you can see the benefits of industrial automation here. So to increase the precision, to improve the product quality, to reduce periodic and manual checking. This is very, very important, because if you put a human operator, obviously there will be a human error. But if you put a machine over there, we can reduce the error. But obviously to make that machine, we want a human. That's a different case. So to increase the consistency in output also, we require a machine. So these are all the very basic benefits of industrial automation. So let's move on to the history of automation. So how it evolved. So there was a time where we were using only manual control, right? For example, let's take a boiler over there, and you have a temperature controller or a temperature indicator over the boiler. Let's take a temperature indicator. So according to the temperature value, you are going to control the flow of water inside the boiler. If the boiler is reading high temperature, you need to increase the flow of water high. If the temperature is getting low, you need to decrease the flow of the water. So there was a time we used to control this system manually. So operator have to be near the boiler and he have to continuously monitor the temperature indicator to get the value, and according to that he will change the flow of water. So there was a time we were controlling temperature using a manual control. So in this case you can find more disadvantages, right? First thing, the accuracy is very less, right? And safety is also matters when we are putting a human over a high temperature boiler, nearer to the high temperature boiler. So these are all the cases which push the man to invert something which will reduce these kind of insecurities in the industries, right? So there was one step above a manual control, there was a pneumatic control. So we were controlling the system using air pressure, and then comes a hard wire logic control, which is nothing but a relay control. So next is electronic control, which used a logic, digital devices, and over that we have a PLC and DCS control. So in each step we found more advantages and more disadvantages. So as we have already discussed, we found more disadvantages in the manual control. That's what we jumped to the pneumatic control. Then we found more disadvantages over that and we moved to the hardwire. And if you see the hardwire, there was a relay control system. If you see a hardwire relay, it is having multiple wires. You need to connect each and every logic using the wire. Fine. So if you want to troubleshoot, it will be a big headache for the operator to find out where is the fault. So this made an engineer to move to the electronic control, where we used some digital logic gates to perform the operation. So then we move to the PLC and DCS control. So let's see more about this PLC in our later classes. So, but in industrial automation, this PLC and DCS are playing a major role, right? So that's in our top, it's in the tree's top. And next we have industrial automation devices. So what is this? What are the components or devices we are going to use it in the industrial automation? So first thing is field instruments. So let's take the same boiler example. So I want to measure what is the temperature of the boiler, right? So for that I need an instrument which is used to measure the process variable. So here the temperature is the process variable. So I'll be using some temperature sensor or transmitter or a transducer to measure the temperature. So that is the field instruments, the instruments which are used for the measurements. That is a field instrument. And by using these field instruments, how we are going to control? So we want some controller, right? For example, if a temperature is going above 90, I want to increase the flow of the water. That's what our case, right? So in this example, to control the flow, I need to write a program inside the controller. So those type of controller are our controller hardware. You can see a PLC, DCS or PID device or in CNC. So where I'm going to write the logic, those are called as a controller. So that will be having a hardware and also a software, right? And the last one is a control software, which is called as SCADA, Supervisory Control and Data Acquisition System, which is used to monitor what is happening in the field. So it's like a visual, or you can call it as a virtual devices in the software, where you can in an industry you can find a control room in one place and a field in some other place. In control room, by sitting in a control room itself, you can monitor what is happening in the field, like a CCTV camera in the shopping hall. It's a simple example for our layman understanding. And that's it about the introduction of automation and the industrial automation. So this is again automation installation procedure. So whatever we have seen in the previous slides, field instruments, control hardware, control software, it will having this flow. A sensor placed in a field, and all the sensors and the wires will be connected to the junction box, and we are getting all the signals from the junction box to the cabinet, where we will be having our controller and IO modules. So from that we will be getting a signal to the SCADA or HMI. And you can find the picture of the field instruments over here, which is giving all the signals to the field box, and we are collecting all the signals from field box to the marshalling cabinet, and from there we will be giving signal to our controller, which is a system cabinet, and from there we are going to watch or monitor. Even we can control also from the workstation, which is nothing but our HMI or SCADA, right? So I hope you have understand the basics of automation and industrial automation. If you like this session, please like and subscribe our channel, which will motivate us to do more in industrial automation course. Thank you so much. Hello everyone, welcome to automation community. In this video we are going to discuss about control system. Before going to the topic, please like and subscribe our channel. So we have some significant words in control system. Those are process, control, measurements and instrumentation. So let's discuss one by one. What is process? So a process is a step-by-step procedure we have to do to achieve the desired output. It's a series of activity in a sequential manner to achieve an desired output. The word desired is very important. What actually I want, to get that you have to follow the step-by-step procedures. So let's take a layman example. if you want to prepare a cake, you want to prepare a birthday cake for your friend. So, and she or he may likes a strawberry flavor, and you have to follow the series of procedures one by one. You have to follow to get a perfect strawberry cake, right? For example, there is a steps, right? So initially you have to mix all the flour in the proper ratio. After that you have to mix it and you have to give some time to settle it down. Later you have to bake the cake pan. You have to heat the cake pan first, and after that you have to pour the the mix, and you have to wait it for some time, and later you have to make it cool, and you have to prepare for the toppings. Like that you have series of steps. If you are mix matching all these steps, you cannot get the proper cake, right? So this is a simple example for the layman to understand what is the process. So one by one you have to follow to get the desired output. Output anyone can get, anyone can bake a cake, but to get the perfect cake you have to follow the procedures. So that is called as process. And the next one is a control. When you are baking a cake, you have to monitor the temperature and you have to monitor the ratio of all the ingredients you are adding. So this monitoring and controlling, right? So if you are monitoring, you will get to know, oh, this is more or this is less, you have to add this. Like that you are taking some actions to get the perfect result, right? That is a control. And obviously the next measurements is the quantity, how much it have to be, that is a measurements. And instrumentation is focused on a design and configuration of the system. So it's a planning. So these are the 4 important words we have to know about control system. So let's see about the definition of control system. It's a combination of various elements connected as a unit to direct or regulate. Obviously control is nothing but to dictate or regulate, right? So itself or any other system in order to provide the specific output. This specific output is nothing but a desired output. So this is called as control system. And we have 2 major types of control system, which are open loop control system and closed loop control system. So as we have already discussed about the example of control system with cake baking, I have one more example here, which is a 4-way traffic light control. Obviously everyone will come across a traffic junction, right? So it's a simple control system to control a traffic, which is comes under our transport automation. In our previous session we have seen the types of automation, and in that we have a transport automation, and this example will come under that. So we will be writing a simple logic to control this 4-way traffic. So first east have to go, and there will be a free left, and there will be a time for people to cross the road, and after that south the vehicles can move to all the sides. So like that at a one time only one side is allowed. So like that we can write a logic to make a simple control system, right? So let's move on to the type of control system, and the main one is, the first one is open loop control system. So what is this open loop control system is, you will be giving some input, you will be doing some process, and you will be getting some output, and whatever the output you have to accept it, or you cannot have a control over that output, right? So let's take one more layman example for the better understanding. You are a operator of one auditorium, and your work is to manage the temperature of the auditorium. I mean, let's take the air conditioning is there, and you are going to monitor or control the the temperature of the whole auditorium where 500 people can sit. Okay, so there was a function and you are the operator over there, and all 500 people were inside, and you are assuming that okay, 500 people is there and the auditorium is this much big, so this much temperature is fine. Like that you are, you have a plan and you have fixed the temperature with maybe let's take one example like maybe around 20 degree. Okay, so the room temperature is 20 degree now, and it's a open loop control system. Like for how I can define this as a open loop control system means you are setting a temperature to the auditorium, and what temperature you have set is the final one. You will be getting some output like okay, you are setting 18 or 20 and the output is also 18 or 20. Okay, but if you see the room, the room temperature is depends upon how much people is also inside, right? So you are not getting any details about how many people are inside. So you are not getting any information like that. Just like that you have set one temperature and output came, that's it. So this is a open loop control system. So for example, if the population is more and they want the temperature has to be bit less, but they don't have a source to tell you, they don't have access to inform the operator to tell that see here this much people are there, so we want more I mean the less temperature. So you don't have a feedback over here. So that is a open loop control system, and whenever you are getting a feedback from the people who is in auditorium, and you will be getting like this much people are there, and you have to reduce this much maybe 2 or 3 degrees Celsius you can less, like that. Some feedback if you are getting means the output should be the desired one, right? So this is for the layman, the example is for the layman, and you can see the input you are giving. Okay, so this is the process, these control element and the disturbances, open loop system, these are all the process actually happening. The temperature is increasing or decreasing kind of, and you will be getting the output. Okay, so you will be getting the feedback signal. See this, the output you want is 20 degrees Celsius. Okay, but the output you are getting is 25 degrees Celsius. So you will be getting the feedback, you will be having an input here as 20 and you will be getting a feedback as 5 degree, like 5 degree less is there, so you have to reduce or increase a bit, like that. You will be having some conclusion here, you will compare here what I gave, what is actually happening. So to get what I want, what is the feedback signal? So according to that feedback signal, you can correct, you can rectify it to get the desired output. So this is actually happening in the industry. So all our industrial automations are working under a closed loop control system. Okay, so without feedback we cannot get the proper desired output. So I'll just explain this traffic light also in open loop and closed loop. Okay, so let's take the traffic light is under a open loop. So you'll be having a program like first east, for east direction 30 seconds, south direction 30 seconds, west direction 30 seconds, and the north is 30 seconds. So it will be circulating 30 30 30 30, and again east people will get 30, again south people will be getting 30. This is an open loop control system. Once it is programmed, means programmed. Okay, so imagine there is a less traffic in south and more traffic in north, right? So south people will, the people who are in waiting for a signal is very less, and they can move within 10 seconds. So the remaining 20 seconds is a waste of time, right? So but if you see the north side, people are more, the vehicles are more, and they want, and 30 seconds is not enough. So in this case, if you are not getting a feedback, what will happen? 30 30 30 30 seconds, in the interval it will be keep on going. But if you have a sensor, or if you have some feedback to get that, see, north side is traffic is more, so you have to increase the time. South side is traffic is very less, and you have to decrease the time. Like that, if you are getting a feedback, means what you will do? Immediately you will change your program, you will increase the time. So for north, give 60 seconds, and for south, let reduce to 15 seconds. Correct now? So like that, we can take a feedback from the field to get the desired output. So this is what we want, right? What is the requirement of, what is the need of automation? So once we were using a open loop control, where the output is not that much considered. Okay, let it be, whatever comes. Like that means open loop is fine. But what actually you want means you have to go for the closed loop control system. So I hope you have understood the basic about control system and its types. So I'll meet you in the next session. So if you like this video, please like and subscribe our channel. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about PLC, Programmable Logic Controller. Before going to the topic, please like and subscribe our channel. So let's split this PLC into three words: Programmable Logic Controller. So let's see one by one. What is controller? We have seen in the previous session about the control system, right? So it is a device. A controller is a device used to get a desired output. And what is logic? A logic is a way of writing a program. So the way how I want a output, that is called as logic. And programmable. Programmable means you can change or you can write the program at any time. In between, if you want to stop the controller and you want to change the program, means you can. So that is programmable logic controller. So this PLC is playing a vital role in control system and industrial automation. So let's see exactly what is PLC. So it's a dedicated industrial computer. So in the industrial term, PLC is also called as dedicated industrial computer. So it's a computer type device used to control equipment in the industrial facility. And you can find PLC in utility plants, batch control applications, chemical processing, conveyor system, food processing machinery, auto assembly lines, etc. So these are all the examples in industrial automation. We have seen traffic light controller example in the previous session, right? So we can write the same logic in PLC also. So we have a very small types of PLC which we are going to see in the later slides. So you can use those small PLC for the traffic light control also. So PLC is not only for the industrial automation, it's also for building automation. You can utilize, you can use it for transport automation also. So why we are using PLC? So it is offering more advantages over the traditional control system, especially relay control system. So the it is having high reliability comparing to the previous control systems. And the space requirement is very small, and it is reduced the cost when it compared to the relay control system, because while it comes to the troubleshooting of relay system, it's really very tough, but in PLC you can able to troubleshoot within 10 minutes, and it can able to withstand harsh environment. As I have already mentioned, it is a dedicated industrial computer, so you can use it in the harsh environment also, where a PLC can withstand high temperature and the humidity also. And expandability, so the number of IOs is huge. According to the application, you can increase or decrease the IOs of PLC. So these are the advantages we can find it in the PLC. And let's move on to the types of PLC. So before entering into the types, we have three major types. One is based on size, and the second one is based on hardware setup, and the third one is based on power supply. So let's start with based on size. So based on size, we have five types: nano type PLC, micro type PLC, medium type PLC, large type, and very large type. If you see the difference between all these five, or mainly depends upon number of IOs. Nano PLC will have very less IOs, below 10, and if you see very large PLC are having 10,000 or 20,000 IOs also we can add. So that's what the advantages of PLC we have seen as expandability, right? So it's mainly depends upon the number of size, and few classification depends upon the communication and the memories. So according to that, we are classifying the types of PLC based on sizes. And we have a second type which is based on the hardware setup. So we have a compact type PLC and a modular type PLC. The compact type PLC is like an integrated type PLC. As you can see in the slide, a simple box is there, and inside that box we have a processor, and over there we have a IO pins. You can see the IO ports here. So you can see the IO ports here, and also we have a output ports. So we have a communication ports here. Inside this processor we have a memories, and everything is integrated. So that's what it is called as compact type PLC. Okay. Instead to that, you have a modular type PLC where a CPU is a different module, IO modules are a different module, and a power supply module is a different module. So in contrast to the compact type system, we have a modular type PLC. So all are plug-in type. So there will be a rack or back plane will be there. You need to plug in your CPU first, and after that you can add the power supply module and communication module and IO module. Like that you can plug in and plug out what and all you want and what and all you don't want. There is a modular type PLC. And the third one we have is depends upon the power supply. So we have with SMPS and without SMPS PLC. So that is nothing but the source voltage we are giving to the PLC. If you are giving 230 volt as a source to the PLC, which is called as with SMPS PLC, and if you are giving 24 volt, to the PLC source, it is called as without SMPS PLC. So these are all the three main classification of PLC. One is depends on size, hardware setup, and based on power supply. If you are going to purchase a PLC for your project, you have to classify first how many IOs you may require, and what type of hardware setup you want, and what may be the power supply you are going to give for the PLC. So depends upon these things you can purchase your PLC. So let's see about the components in the PLC system. So let's see this picture first. So we have an input module here where you are having all the field instruments. So switches, transmitters, transducers, sensors. So these are all the input devices. So these devices should communicate with the CPU, right? So for that, IO module is act as a communication bridge. And we are also having output devices like motors, solenoids, contactors, VFD, So these are all the output devices, and these has to communicate with the CPU using the output module. And we have a power supply common for all these. IO modules also require power supply, and CPU will also require power supply. And we have a programming device over here. The use of programming device is nothing but to write a program. So as I have already told, PLC is also having a software, right? So these are the hardware setup, and this programming device is a software setup. The program have to be, the software has to be installed, and we have to write the program, and we have to download that to the CPU to run the application. So we have a PLC processor, IO module, chassis or backplane. Chassis or backplane is nothing but this rack. The backplane I have explained, where we will be plug in and plug out. So that is a backplane. And we have a power supply, and we have a programming software that runs in the PC. So PC nowadays it is used as a programming device, but in the olden days we were using the handheld devices also. So the device will be very handy, and you can write a small program in that. So handheld device were used, and the purpose of central processing unit. It's a part of the programmable controller that retrieves, decodes, stores and processes information. It also executes the control program stored in the PLC memory. It functions in the same way as CPU of our normal computer. The IO module, as I have already told, it acts like a bridge between the CPU and field instruments. So this IO system consists of two main parts. One is rack and the IO modules. Rack, as we have already discussed, a rack will be like this. It will be like a long, horizontal kind of plane where you will be plugging all your devices. Modular components of PLC like power system, CPU, analog input module, analog output module, digital input module, digital output module, everything is connected with this rack type. That's what it is called as the rack and IO modules. So the rack has to be at the back, act as a backplane, and the IO modules will be fit into that. So the rack is an enclosure with the slots. So the plug-in is using these slots only. So, and that is connected to the CPU. IO modules are devices with connection terminals to which the field devices are wired. So modules, as I have already told, this is a separate module. Whereas in integrated system, IO module is complete this slot. This complete line will be the input module, and this complete line will be the output module. But here in modular type of PLC, we have a separate module. That's the difference between those two. So IO system is what actually physically carries out that control commands from the program and stored in the PLC memory. So the once the program is downloaded to the CPU, the CPU will read the information from input, and it will run the program, and it will fetch the output. So like that only it works. And this one also we have seen, and it's a modular PLC and rack based system. You can see the rack is behind the plane and everything is connected to that. And we have more vendors for PLC. In that the more familiar vendors are Modicon, AB, ABB, Omron, Siemens, Delta. So these are all the popular vendors for PLC, and so more are there like Honeywell. There are so many PLC vendors are there, and for each PLC they will have their own software for that. For example, if you take Siemens PLC, we have a Schematic Manager. There is a software for the Siemens PLC, and you cannot use any other PLC for the Schematic Manager. So AB should use only RS Logic, and ABB will be using the codesys, and codesys is a common language for some other PLC also. So like that you have global software also and dedicated software, vendor based software also it is there. So that's it about the PLC. So I hope you have understood the basic concepts and the components and the purpose of PLC in the industry. If you like this video, kindly like and subscribe our channel. I'll meet you in the next session. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about PLC programming. So before going to the topic, please like and subscribe our channel. So let's see about PLC programming. So we have seen the basics of PLC in the previous section. So there we have seen a programming device which is a PC. And in that PC, we will be downloading the software of PLC and we will be start writing the program. And there will be some special instructions will be there for writing the program. So we are going to see the basic instructions we will be using in the programming. So what is PLC programming? So to design and implement the concept in controller, we are using programming tools. PLC software built with plenty of instruction to write a logic. As I have already told in the previous session, each vendor is having separate PLC programming software. But in common, we can do the PLC programming using 5 languages. Let's see what are the 5. So we have a ladder logic. So ladder logic is a more familiar and widely used programming method. So the second one is functional block diagram, and the next is sequential function chart, and the next is structured text, and the last one is instruction list. So there are 5 ways to write the PLC program. So which way is convenient for you? You can choose according to your requirement. So in this course, we are going to see in ladder logic. So let's see the basics of ladder logic. So the name itself, it's telling a ladder. So it will be having 2 rails which are called as power rails. One is positive, another one is negative. So this is positive and this is negative. So these are the power rails where the power always flows from left to right. From this side to this side, the power will flow. So we have 3 major instruction or the important terms in when it comes to the programming. So those are normally open contact, normally closed contact, and output coil. Okay, so what is normally? Let's see about normally open contact. So it is like a switch. Imagine you have a switch at your home, right? So you will be turning on, your output will be on. If you turn off, your output will be off. So that type of switches are always called as normally open contact. What is this normally open contact means? Basically, it will not allow power to flow. If you are disturbing the state of the switch, it will allow to flow. Like how is in our home. Initially, the fan or the light will be in off condition only. If you turn on the switch, it will allow power to flow into the fan so that the fan is rotating. Right? So those type of switches are called as normally open contact. And we have one more contact which is called as normally closed contact. So it is just opposite to normally open contact. So normally closed contact will be always allowing power to flow. Imagine your fan is always in on condition. If you disturb the switch, your fan will off. That's it. That is normally closed contact. And we have an output device which is nothing but, in our example, it's a fan. It's output. Fine. So this may be an input and that will be connected to the output. If you turn on, it will on. If you off, it will off. When it comes to normally closed contact, initially your output will be in on condition. If you disturb the switch, it will be going to off condition. So that's a very basic about ladder logic. So let's see one example for the ladder logic. To turn on a motor using a switch. Okay. So I'm using one switch and I'm connecting one motor to this. So I'm using a normally open contact here. Why I have used a normally open contact here? Because I want to turn on a motor by using a switch. So if I disturb the switch, the motor has to on. So what will happen? Power is here. 24 volt power is here. So this is plus, this is minus. So initially, as we have already discussed, normally open contact will not allow the power to flow from left to right. If you turn on, if you disturb this switch, it will allow this 24 volt to get into this, so that it will reach our output, which makes our motor to on. That's it. It's the simplest example to understand the normally open contact. Okay, let's see one more example here. To turn on a motor using switch 1 or switch 2. So I have two options to turn on a motor. So when it comes to option, I'm using a OR logic. This or this. If you turn on switch 1, motor will on. Or if you turn on switch 2, that time also motor will on. So that's it about example 2. To turn on a motor using two switches. So I'm using normally open contact here for both, because I'm going to make a contact. To make a contact means mostly we will be using a normally open contact. And we have the third example. To turn on a motor using switch 1 and to turn off the motor using switch 2. So to make a contact, to make the contact in the sense to turn on a motor using switch 1. So for that I am using a normally open contact. To turn on a motor, to make a contact, I am using switch 1 connected to motor. To turn off the motor. So to break the contact. To break the contact, I am using a normally closed switch to break this line. So what will happen? Already switch 1 is on, so that the contact is, the power is running from left to right. So motor is on. If you disturb the switch 2, what is the feature of normally closed contact? Initially it will allow the power to get in, but if you disturb, what will happen? The contact will break. So that what will happen? Motor will be in off condition. So that's it about normally open and normally closed contact, and this is the basics of ladder logic. So we'll see more example in the upcoming session. I hope you have understood the ladder logic. If you like this video, please like and subscribe our channel. I'll meet you in the next session. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to discuss about Omron PLC. Before entering into the topic, please like and subscribe our YouTube channel. So let's see about Omron PLC. So Omron is the leading brand. If you see in our industries, most of the companies are using a Omron PLC. So it is a well-known brand in our India also. So there are dozens of manufacturers of PLC. As we have known, we have seen so many brands in our previous sections, right? So one of the leading maker of compact PLC for machine automation is Omron. Omron offers a flexible line of scalable industrial PLC controllers for use in single machines or as part of large machine control installation. So let's see more about Omron PLC. So the structure will be like this. This is similar to our components of PLC. The generalized architecture of PLC. So we have an input module over in the left side, and we have output module here, and all the input devices are connected with input module, and output devices are connected with output module, and we have a CPU, and inside that we have a processor and memories, and we have a software for that, and communication and power supply module will also be there. So if you see, we have more signals, like we will be having digital signal. So input module is the one which can able to collect all type of signals, right? So suppose if your project is having only digital input, means you can go for digital input module. Or if you have analog input, then you have to go for analog input module. And if you have a pulse input, means you should go for the pulse input module. Like that, input modules are differentiated into 3 types. According to your application, you can pick whatever you want. And same thing for outputs. So these are all the types. You can see for digital, the first one is on-off state. This is nothing but a digital IOs, and for that you have an input device as push button, some switches, sensors, relays. These are all will come under digital inputs. And outputs, you can see indicators, lamp, just a display, relay, contactors. These are all digital outputs. Let's see about analog IOs. So we have a transducers or transmitters, and all will come under a analog input. And analog output you can call VFDs, inverters, and all will be the analog output. Control valve, these and all will come under an analog output. And we have a pulse IOs also. So encoders and photo microsensors are pulse input. Servo motors, pulse motors are pulse output. So depends upon our IO type, we will be choosing the IO modules. So in our Omron section, we have a modular type PLC, compact type PLC, and rack type PLC. So I hope you are familiar with modular, compact, and rack type PLCs. So we have a Omron models. You can see here CJ2H, CJ2M, CP1H, CP1L, CP2E, CSIGH, CSID. So these are all the types of Omron PLC, and these types are classified into 3 types. So if you see a modular PLC, inside that we have CJ2H and CJ2M. So if you can find the IO capacity, the total number of IOs we can add is 2560, and the program capacity of 400k steps, and this is having 600k steps. So in our previous section, I have mentioned that PLCs are classified depends upon the size and that is mainly depend upon number of IOs, communication protocols and memories. So here also they are categorizing the PLC, Omron PLC type into these three sections. Number of steps, number of IOs and the program memory. You can see the compact type PLC capable of having 320 IO points. Points is nothing but IO, and this is having 180. Rack type PLC are having more. 5120 points you can add. So depends upon our requirement, we will be choosing the type of PLC we want. And you can see here, these are all the integrated type PLC. In a single kit, everything will be here. In a modular, you have option to add IO modules. And in a rack type PLC, also, it also like modular type PLC, and you can add expansion rack also. For example, in this rack you have a 10 modules. Since your project is big, you have to add one more rack, means you can able to add. So those options are given in rack type PLC. That's what the IO points are more. So this is a compact or integrated type Omron PLC. CP1L. So we have a input ports and we have a output ports and we have a indicators. So indicators for troubleshooting, we will be having a LED indicator, so it will easy for us to troubleshoot. And this is similar to the previous slide. So it is showing the graph of maximum IO capacity and functionality. So the rack type PLC are having a maximum IO capacity. And some modular type PLC. So this is the section where you can attach your nearby IO module. It's like a plug-in type. You can attach the module which you want to come next to this. You can plug in to this port. It's a rack type. So CPU is there, power supply module is there, IO modules are there, communication module will also be there. So Omron PLC rack type. And as I have already told, in a rack type you have an option to add expansion rack also. So in one rack you can add maximum 10 IO units, and for one rack you can add 3 extra expansion rack. That's what here they have given, expansion rack 3 maximum. So you can communicate between these racks using the IO control unit. So using this IO interface unit, you can able to communicate with your main. This will be the master. This is the main rack, and from this we have added the 3 expansion rack. It's a rack type PLC. And let's come to the communication part. So what are the types of communication we are going to use for writing or loading the program? Writing a program using a software, and after that to load the program or to make the communication between our CPU and our field instruments. So these are all the types. The device net, Ethernet IP, Ethernet CAT, and Profibus DP, serial communication. So here they have given CS1, CJ1, CJ2. These are all the types of Omron PLC. So these are all opt for device net. So if you choose any one of this type, you can have an option to use this device net communication and Ethernet IP, and this is Ethernet CAT. This is Ethernet for control automation. Ethernet for control automation. So this is for NJ and CJ2. For these two types we have this option. So this is also similar to Ethernet only, but we have response time is more comparing to Ethernet. So that's what it is dedicated for the control automation purpose. And we have a Profibus DP and CS1, CJ1, CJ2. See, DeviceNet and Profibus DP. So all these models are having DeviceNet also and Profibus DP also. So Profibus DP is also important protocol. People started using in industries. So it is used to operate sensors and actuators through centralized controller, and this is open, and this is independent network standard. And we have a serial communication. So using RS-232, we can able to make a communication between PLC and devices. So that's it about the communication protocol. So we have an option to connect remote IO connections also. So using terminals, we can able to, using the remote terminals, we can able to communicate our PLC with remote devices also. So you can see here, we have a remote terminal, and using that we are communicating with IO devices, input devices, output devices and all. And this is Ethernet. So for loading and uploading a program, we will be using the Ethernet. And between a controller to controller also, you can able to make communication using Ethernet. And this is Ethernet for control automation. So if you have some drivers and you want to have some faster response time, means you can able to use this Ethernet for control automation protocol. And we have a Profibus DP. So all sensors and the sensors and output devices will be in the factory floor, and you will be having PLC in the control room. So the distance maybe in some companies the distance may be more. So in that case, to reduce the number of wirings, you will be using the Profibus DP protocol. This is about the serial communication. So now serial communication PLCs are very less. In our previous days, we were using, all PLCs were coming with RS-232 port. Nowadays, at most all PLCs are coming with Ethernet port. So serial communication is reduced. So this is one more type of Omron PLC. So when you have some servo motors to control some motion control application you are having, means you can go for these series of Omron. So you will be having one of the module, and after that you will be communicating your drivers. This will be this separate servo drive to communicate with PLC want to communicate with servo motor, means you have to use the respective drive, servo drive we have to use. So NJ series will help you to communicate with the servo motor in Omron. And at last we come to the software, what software we are going to use in Omron, which is CX1 software. So CX1 software, it will allow the user to build, configure and program Omron PLCs, HMI and motion control systems and network using only one software package. So CX1 is one complete package. In that you have PLC and HMI and motion control softwares also. So you can use this one pack to program all these three. And this is the OS version. So you can install in Windows 7, 8 and 10. So PLC means you have a CX programmer, switch box utility and CX simulator. These three are used for PLC. And for HMI we have a CX designer, and there is one more option will be this SCADA, that is CX supervisor, And for motion, you can use CX drive, CX motion, and position and all. For process, we have some softwares in Omron, and this is for the network. So that's it about introduction to Omron PLC. So in this, I have few more slides about syncing and sourcing inputs. These are all the types of inputs. Later in the later section, I'll explain this. So I hope you have understood about Omron PLC and the types. So I'll meet you in the next session. Before that, kindly like and subscribe our channel. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about data types in CX Programmer. Before entering into the topic, if you are not subscribed to our channel, kindly subscribe to get more updates. Data types in CX Programmer. So what is data type? Data type is used to define the size of the variable we are going to use in the programming. Knowing data types of our input and output we are going to use in programming is very important. So, it is the data size of the symbol from the initial address in the IO memory and the type of data stored there. Let's take one digital input. Let's take a contact, NO or NC, whatever it is. So, this will come under a digital input, right? So, the operation of this NO or NC will be like 0 or 1, on or off. So, it will come under a Boolean. It will be a binary input. So, it can operate only with 1 or it can operate only with 0. There is no in between number or there is no less or greater than 1 or 0. So, 1 means on, 0 means off. In some cases, 0 is on, 1 is off. Like that, you can define the input according to the requirement. So, like that, we have few more data types. Those are integer, real, word, string. So, data types are used to monitor the values in IO memory with CX Programmer. So, we have basic data types. So, those are all Boolean, integer, double integer, long integer, unsigned integer. So, like that, we have more data types. So, all these data types we will be using in the programming. Even timer and counters are also coming under data types in CX Programmer. So, let's see about its size. So, as we have already discussed about bool, which is called as Boolean. This is the bit data. You can see size is 1 and 0 means false and 1 means true. It's a single bit. The size is a bit, number of bits. So, if you take an integer, that will be a 16 bit. Correct. So, integer is a 16 bit and you can take a byte, which is a 8 bit. So, for the 16 bit, the range is -32768 to 32767. Suppose in your program, you are using an integer as a data type. You are declaring one variable. Let's take one practical example. You are going to get the water level in the tank. So, you are keeping a level transmitter. So, for the level transmitter, you will be defining some value. Like you can measure the quantity of water in the tank. And that quantity of water in the tank, you want to read it in a PLC means you need to declare that as a variable, right? So, that variable may be an integer or a double integer according to the size of the quantity. You can declare the variable here. So, while declaring that variable, you are supposed to use the range.
For example, if you are declaring the integer as that variable, you can only use between these numbers. Right? Suppose your range is more, means you can make use of this double integer. So comparing to integer, the range is more because the size is more. So here for the double integer, we have a 32 bit. And for the long integer, it is 64 bit. And when it comes to the unsigned integer, there is no negative value. It will be 0 to 65535. Like that, for each and every data type, we have a range here. For the timer, look for the timer. We have a timer number. So this many timers you can make use of it. And this is the number of seconds we will be giving, the maximum number of seconds we can give. So like that, we have multiple data types here. According to that, you need to declare the variable, and the variable you have declared will be in this range only. So it depends upon our application, right? So according to my application, I will be choosing the variable, right? So that's all about the data types in CX Programmer. I'll meet you in the next session. Before that, if you are not subscribed to our channel, kindly like and subscribe. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about Omron software download and installation. Before seeing that, kindly like and subscribe our channel. So I have given a link over here, and also in the description, you can find the Omron software installation link. Just copy and paste it in a Google. So it will direct you to the Omron official website. So this is the official website of Omron. As we have already seen, CX1 is the complete package for Omron software. You have to create a login by giving your email ID. Just create a login here. After that, you will be getting a download link. So if you click on that, your installation will, the download will start. So since I have already downloaded, I'm going to cancel this. So once you have downloaded, you will be getting a zip file. If you extract it, you will be getting a two files. One is the setup one, and we have a key also. So just click on this. You will be getting a setup link. So we have a setup file here. So right click and run as an administrator. Just follow the procedure. It is not very tedious and all. It is very easy for the installation. Just accept the agreement, and it is asking for the key. Just go to the folder and get the key. Type it here, 1600. So just click some company name. Go for next. Choose the language. Go for next. Choose the complete setup. Go for next, and where you want to save it, choose the place. That's it. The installation will get start.
It will take some time for the complete installation. So the installation has finished, and you can find the folder in the C drive. In the C drive, program files, and there is a folder called Omron. Inside that you can find the softwares installed. Just go for CX1. Inside that you have a CX programmer. Open that, and there is our PLC software. So CX programmer is the software which we are going to use it for our programming. So that's it about the installation of CX1 software. I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. Today in this session we are going to see about what are the tools and options in CX Programmer software. So before entering into the topic, please like and subscribe our YouTube channel to get more updates about the course. So let's see about the tools. So this is the landing page once you open a software. So we have a title bar here, so which will be giving the project name and the software name. And we have a menu bar here. So as usual in all softwares, we have a file, edit, view. Those kind of menus will be there in the menu bar. And we have a toolbar here. So where we will be getting the options for all the instructions. And this is the project tree. Here only you will be getting the project name, and if you want to add any other subroutines means you can add over here. So in this project tree, in this section 1 only we will be writing the ladder logic program. So this is the programming area. This place is the way we will be writing the program. And we have a symbol bar here, status bar here regarding what are all the errors or output will be showing over in this status bar. And this is the project workspace, as I have already told. Here only we will be writing our ladder logic. And this is the output window and also the status window. So what is the function of all those windows? You can see here title bar, just show the file name, and menu is to enable the items, and toolbar will give some dragging toolbars, enable you to change the display position by the group. This is one of the toolbar. Like that we have so many toolbar which will be helping for customization of the software. And section, it is used to enable you to divide one program into given number of blocks. Each can be created and displayed. So like subroutines you can create under the sections. And project workspace or project tree where you will be writing the program. Ladder window, it's the same as project workspace. And output window will show you the output results and errors. The status bar shows information such as PLC name, whether it is an online or offline and all. Information window, it shows some shortcut keys used in CX Programmer. And symbol bar displays the name, address and value and comment of the symbol presently selected by the cursor. So I'll show you in the software. So this will be the menu bar, toolbar and all. So in the later session I will show you the project window, status bar, information window and all. I will show you in the upcoming section. So that's it about the tools and the instructions, and this is the CX programmer information. So this is the shortcut for this toolbar. In toolbar also you will have this instruction, and here also you have. So that's it about the tools. We are going to use it in the CX programmer. I'll meet you in the next session. Kindly like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about CX programmer instructions. Before entering into the topic, kindly like and subscribe our YouTube channel. So CX programmer, the programming software for all Omron PLC series. This and all we have seen already. So in this slide, in the upcoming slide, we are going to see the instructions we are going to use it in the software. So these are all the sequential instruction. So load, load not, condition on, condition off, logic gates with LD, load and load not. See, each software is having different technical name. This is nothing but a open contact, and this is nothing but a close contact, NO contact, NC contact. But in Omron it is called as load and load not. So like that we have a technical names here. So once we enter into the software, we'll see how to use this and all, we'll see over there. And this is the sequential output. So output, this is nothing but a coil, and this is a rising edge, and that is called as DIFU, differential up and differential down, falling edge. This is the reset bit, and this is the set coil, reset coil. So these are all the inputs instruction, and these are all the output instructions. And next to that we have a comparator functions. So comparator function is used to compare two values, whether it is equal or not equal, greater than, less than, like that we can able to compare two values. So equal, not equal. So here we will be using this symbol. This symbol between two values mean we are comparing these two values, like that. So not equal means you have to use this symbol. So the next is the data movement instruction. So it is used to move the value from one place to another, one address to another. So like that we have three instruction in the data movement, and we have a timer and counters also. So timer used to create some time delay, and we have a types of timers also. On delay timer is there, off delay timer, retentive timer, cyclic timer. So we'll see once we enter into the software programming part. So the next we are having increment and decrement. So incrementing the value and decrementing the value. So these type of instructions are used for that. And we have a mathematical instructions, addition, subtraction, modulo, multiple, divide, everything over here. And we have a conversion. A number is converted from BCD to binary means you can make use of these type of instructions. Those are all conversion instructions. And we have a logic instruction With this you can perform all logic gates, AND gate, OR gate, NOR gate, NAND gate, you can able to do with these instructions. And we have a data control, limit control, PID and scaling. So these three instructions are comes under a data control instruction, and this is the shortcut name LIM. If you take a empty box and if you type LIM, it will convert it to the limit instruction. So the bracket, inside the bracket there is a name, no, there is a instruction name in the Omron. So like that, for PID is there, scaling is there, and subroutine instructions SBS, SBN and return. So these three are used for subroutines. So that's it about the instructions in the Omron software CX programmer. So I'll meet you in the next session. Kindly like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about addressing in Omron PLC. So, we have a IO memory areas. So, these are all the area where we are defining the address. So, we have core input, output, we have work area, holding area and registers. Few registers are there, and also we have timers and counters. So for all these operation we have a address. So let's see about that. First, core input and output. So the input addressing in Omron will be starting from 0.00. So this 0 is a channel number, and this 1 is the and the next 0 is the terminal number. So like that it will start. So 0.00 up to 16 we are having here. So 0.00 to 0.15 is the first channel. Next that it will start with 1.0, 1.1, like that it will go. So that's it for input addressing. So input address of Omron will be like 0.00. It will start from 0.00 and it will go till 6143.15. Right. So let's see about output. So for output addressing, we will be using 100 series, 100.0, 100.7, 101.0, like that we will be using for output addressing. So in the integrated type PLC means you can use 0.00 and 100.00 for IO, input and output. If it is an expansion module input, you can make use of 2.0 to 9.0. So it is like 2.0, 2.1, 2.2, like that you can name it for the expansion module IOs. And if you want to use some memory coil means you can make use of 10.0. So memory coil in Omron is addressing as 10.0, 10.1, like that. So expansion module output address will be starting from 102.0, 102.1, 103, 104, like that it will go for expansion output module. So for input 0.00, for output 100.0, and for memories it will start from 10.0. So the next is the work area. So these are all for the registers. The memory area in which address starts with W, the work area is used only in programming. So you can utilize these 16 bits for the word. And we have the DM area. So it's for 16-bit units.
So once we started the instruction, you can understand where and all we are going to use these kind of addressing. And we have a EM area. So this is for a general purpose memory area that can be write and read in 16 bit. So you'll be using this complete 16 bit for one word. So the EM area will hold the previous data when the operating mode is changed. So holding registers will be having the address of starting with H. So H, if you in a prefix, if it is H, we can get to know there is a holding register address. So this is for the index registers. So IR0 to IR15. So we have a 16 index registers. And along with these registers and addressing, we are having some flag for the Omron PLC. So these flags will be default. If you are in need of any flag in your program, you can make use of it. For example, if you are using this particular flag, that will be meaning that greater than flag. If you want to compare any two values, you can put this flag in between. You can check. And we have some error flag is there, clock flag is there. And we also have always on flag and always off flag, which means whenever the CPU is on, this flag will be continuously on. So you can make use of this flag to turn on some output. Whenever your PLC is on, you can able to turn on an output using this flag. There no need to connect any memory coil or any other input address. You can directly use this flag to turn on that particular output. And this is for always off flag. And we have a data register used for the indirect addressing. And TR bits, when you are using several output branches, and interlocks cannot be used. In that case, you can make use of this address to store the output value. And we have a counter area, and in Omron you can make use of 4095 counters. So the addressing will be starting with C000, and one more counter if you are using, that will be C0001. It is not that you need to use a sequence in order, nothing like that. You can make use of any address in between C0 to 4095. Same thing for timer also. The addressing will be starting with T000 to T4095. So if you are using one counter and one timer, for counter you will be using C0000, and for a timer you cannot use the same address. You should give something different. It will be like C00, that 0000 is already used for counter. So you should use some other address for the timer. So like this we have addressing in Omron. So once we start the programming, we can make use of this addressing for our IOs. Kindly like and subscribe our YouTube channel. I'll meet you in the next session. Thank you.
Hello everyone, welcome to Automation Community. In this section, we are going to see about PLC Operating Modes in CX Programmer. Before entering into the topic, kindly like and subscribe our YouTube channel. So, PLC Operating Modes in CX Programmer. We have multiple modes in the programming software. So, let's see one by one.
So the first one is programming mode. So obviously to write the program, we have to be in this programming mode, right? Whenever you are creating a project and you want to write a logic, means you have to be in the program mode. So this is also used to transfer the program from your software to PLC, right? And you cannot able to see the output in the programming mode, and you can able to force a bit or coil. So forcing is possible, but you cannot able to see the exact output of the logic you have created in this program mode. So the first mode is program mode, and the next one we are having is a debug mode. So in the debug mode, you can able to check the IO operation and program execution. If any error, suppose you have written 100 lines, 100 runs of logic you have done. So after that, you want to check if you are having any error or anything you have missed out, means you can go to the debug mode. It is like a compiler, and you can able to see where you have done the fault before entering into the next stage. I mean, before entering into the exact execution, you can enter into the debug mode to check whether you have missed out something or any error in downloading the program from your software to PLC is there. If it is not there, you can go on. You can move on to the next mode. So debug mode is nothing but a compiler mode. So the next one we are having is the monitor mode. So the program is executed and IO operation is actually active. You can change data from one place to another, and editing is also possible in this monitor mode. And we have next is run mode. So once you have done the program and you have compiled it and you have also monitoring, ready to monitor, means you can go on to the run mode, where this is like a final testing. So what and all logic you have done, you are going to see the result in the run mode only. If the PLC software is not in the run mode, you cannot able to see the updated or the current status of output. And in this mode, you cannot able to change or edit a program. So this is only to view what exactly happening, right? And the changing is telling for the outputs. So in the run mode, you can able to change the program. Fine. So it is like once you have done the program and compile it, you can able to see the output in the run mode. Suppose if you are using in the simulation version. So I'll show you in the next slide. We have one more mode which is called a simulation mode. So if you are not having a PLC but you want to check the logic, means you can use the simulation mode. So in this simulation mode, if your PLC is in run condition, you can able to force your input to see the status of output. So this online editing is possible in the run mode, but before that have to be in the simulation mode. So I'll show you this once we are entering into the exact programming. So the first mode is program mode, debug mode, monitor mode, run mode, and simulation mode. So that's it about programming modes in CX Supervisor. I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about how to create a new project in CX Supervisor. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So let's open a CX programmer. So this is the landing page once you have opened the PLC software of Omron. So after that, you have to go to the file and create new. And there is a shortcut for this that will be a Control plus N. So just click on that. So it will take you to the PLC option to choose the name, right? So you can give the name of the device name of the device. So let it be as new. This is the default name they have given. So let it be like that. And there is an option called device type. So this is the type of Omron PLC. So you can see there are multiple types over here. So everything, all these are comes under the Omron. So for our project, we are going to use the CP1E, and we have multiple types MH, ME. There are so many types over here. So I'm going to use this CP1E type. So I'll give them some gist of information about this. So if you see the E-type is the basic model of CPU unit that supports basic control applications using instructions such as basic movement, arithmetic, and comparison instruction. So E-type is the basic type of Omron. And we have N-type. N-type is the application model, so which supports some terminal connections, some inverters, servo drives. So these are all some application type of devices, and which you can connect to the N type of Omron. So you cannot connect inverters and servos in this E type. And we have NA type. This is also application model. We have advanced application model. So like this, I'm just giving an example. Like this, you have multiple types of PLC. As you have seen here, there are some H, L. So you can get all these information in the user manual. So once you have selected the device type, go to the settings. And this is a CPU type. See, in this CPU type, depends upon your selection, it will show here. So what is this E10, E14, E20? Like that means this is the number of count of IOs. So how many IOs you are going to use in your project? According to that, you have to use this numbers. So I'm just using E20 and just go for OK. And network type. So let it be as USB. So just go for OK. So our new project is creating. So it's created. It's created now. So here you can see the name, device name of your PLC. Since I have not given any name, it is taking the default one, right? And here we have a programming area. So here only we will be writing the program, and that will come under section. So if the tree is like this, you have to expand it. You have to expand the tree, and there you can find the section area. Here only we are going to write the program, right? So how to write a program and how to take all the instructions and all will be seeing in the next session. So before winding up the session, kindly like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. Kindly like and subscribe our YouTube channel for more updates. In this session, we are going to see about NO contact. So let's see all the basics about NO contact, which is also called as normally open contact. So in the ladder logic, this is one of the important instruction because this is the one throughout we are going to use. What may be the project in ladder logic without NO contact?
it is impossible to write the logic. So let's see about this NO logic in CX programmer. So you can find NO instruction here. So I'll just name this instruction. Let it be a switch 1. So if you see NO contact, in simple I can say the switches we are using in our home, that is a NO contact. Why it is like that means, if you turn on, the position of the switch will get changed so that the corresponding output will turn on. Maybe the lamp or fan, what may be the home appliances. If you turn on the lamp or the output, the corresponding output will get turned on. So that is a perfect example for NO contact, normally open contact. What is this normally? Why the name is called as normally open contact means it doesn't allow the power to flow, but when you change the position, it will allow. So normally it will be open. If you disturb the state of the switch, it will get close. Understood? So let's connect an output. I'm taking one coil here and I'm connecting that as a output. So let's say this is the tube light we are having in our home. Okay. So this is our tube light switch. I'm connecting. Okay. So this is a logic, right? So ladder logic is the logic behind the home appliances. So imagine like that. So you have a switch here and you have a tube light here. So now if you see, there is a power flow here. Okay, so this is a positive rail and this is a negative rail. So from positive rail to negative rail, power have to flow so that the power will reach the tube light. Okay, so in the ladder logic, the flow of power will be like left to right. So it is starting at left. Have you seen there is a green color over there? No. So it is like power is going before before the NO contact. It stopped before the NO contact. Why? Because the contact is opened. So since the contact is open, it is not allowing the power to flow inside. Understood? That's what our tube light is not yet turned on. Okay. In layman example, like if you are traveling from one place to another place, okay. So while you are traveling to your destination, there is a block. So maybe a traffic police is they have put some barrier or some disturbance you are having over there. So you couldn't able to reach your destination. So that restriction is now this normally open contact, which is not allowing. So what we have to do, we have to remove the barrier or we have to pass through the barrier. Alright. So for that what we have to do, we have to change the position of the switch. So if you want to turn on the tube light at your home, what you will do, you will be turning on. Turning on is nothing but changing the position. So what I am going to do, this is already off condition. Correct. This is already off condition. What I have to do, I want to change from off to on. Let's do that. Okay, I'm going to do on. So once I have turned on, the power which was stopped before the NO contact is now going through NO and it is reached the destination, which is the tube light. So have you seen the tube light is on? Now, if you want to turn off, what will happen? The power will come back to this, the previous location. So it's allowing, it was allowing before, now it's not allowing because we have changed the position. Alright, now again change it. You can turn on, you can turn off. So this is normally open contact. Normally open contact means it will never allow the power to flow. If you are allowing, if you are changing the position, it will allow. So that is normally open contact. And what if one more switch is here? So let's see that also.
I'm adding that as switch. Okay, I have given the same address. Okay, let it be a switch 2. So let's go online and check. Now you have a 2 input. So the power has to reach the tube light, means it have to cross 2 normally open contact. So what I have to do, first we have to pass 1 input. See, it crossed the first input. Now this is blocking. Now what I have to do, I have to turn on this also. So both the inputs are in series. So that's what, it's like a condition, under condition. Both have to be on to turn on the tube light. Okay. If you are having some option, means what if the switch is over here? So let's connect. Alright. So now what will happen? Let's see. So now the power is at this location and also this location, because switch 2 is directly connected to the rail, positive rail. So switch 2 will also receive the power, switch 1 will also receive the power. Now let's see if switch 2 is on. See, tube light is on. It's like a 2 switch for 1 output. What will happen if you turn on the first input? Same, because your output is already on, even though if you turn it on again, I mean the second input is on, nothing will happen because tube light is already in on condition. If you turn off the second switch, what will happen? Now the power is flowing through the switch 1. Tube light is still in on condition. Now if you turn off that input also, then your tube light will go off. So this is how normally open contact will get work in ladder logic programming. I hope you have understood the normally open contact. I'll meet you in the next session with normally closed contact. Before winding up the session, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about normally closed contact. So, as I have already told, normally open contact is one of the important instruction in ladder logic. Same like normally closed contact is also one of the most important instruction in ladder logic programming. So, let's see in CX programmer. So here you can see this is normally closed contact. So I'll give the name, which is a switch 0 already. So what is this normally closed contact? Why it is called as normally closed? If you see, there is a difference between normally open and normally closed symbol. Look at this. Look at this. This is normally opened. If you see, the normally closed is having one cross line from right to left. Have you seen? This is normally closed. So how it will work? So let's connect this with one of the output to understand this. So same tube light I am taking. We have seen this in the previous concept. The tube light I have taken. Okay. So imagine you have one normally closed switch at your home for the tube light. So let's turn on the main supply, which is I'm going online. Let's see, you have not done anything. You have not changed the position of the switch, but your output is on. Your tube light is on. Once you turn on the main, your tube light is on. Y. Y means there is a positive rail over here and a negative rail over here, right? So the power from positive rail is easily flowing through normally closed contact to reach the destination. Can you see? A normally closed contact is allowing basically the power to go through it. Alright. So, but in the previous session, we have seen about normally open contact, which is restricting the power to flow unless we change the position. But this is allowing. So, that's the difference between normally open and normally closed. So, initially it will be in the closed condition, which will be allowing the power to flow. If you change the state, the power will get restricted and your output will be off. So, normally closed conditions, off condition is like this only. It is not that normally closed condition now in on condition, not like that. So, normally closed condition is designed in such a way that it was in off condition, but it will allow the power to flow. It's like opposite to normally open contact. If you disturb the state of your normally closed contact, it will restrict the power to flow from positive to negative so that your output will get turned off. Understood? So, what happen if I connect two normally closed contact in series? So, let's see that also. Let's go online. Now, see, both the inputs are allowing power to get through it and your output is on. Okay. Now, change any one position, changing the position of switch 2. So, your output is immediately turned off. Because both are in series, one is restricted means power is stopped here. Alright. So, now I'll go back to the previous state. Now, your tubelight is on. Just disturb the state of this. What will happen? So, power is restricted here itself. So, power is not allowing from left to right. If you see switch 2, which is on, which is having some power, but without the power before this, nothing will happen. Power have to be cross switch 1 to reach the switch 2, but it is not happen, so your output is off. Okay. So, now I will turn it on, turn off it again. Now, see, your tubelight is on. Alright. So, now I am going to connect this in parallel. Let's see what will happen. That's it. Let's go for the simulation. Now, as usual, both the inputs are in off state, but your output is on. So, let's cut down one of the input, but it's not affecting the output because both are in parallel. Parallel means option. So, if the power is restricted here means it will take this route to reach the tubelight. See, there is no restriction in this line, so it is taking this route. Okay. So, now disturb this. Now, what is happening? So, it is taking this route to reach the tubelight. So, this is how normally closed contact will get work. Okay. So, what will happen if one normally open and one normally closed? So, let's see that. So, I'm going to use switch 2 as normally open and switch 2 as normally closed. It's switch 2 as normally open and switch 1 as normally closed. Now, see, your tubelight is off. So, I am going to turn on my switch 1. Tubelight is on. If you turn off the switch 2 or turn on the switch 1, tubelight will off. Okay. So, this is normally open and normally closed and this is coil. So, these three instructions will come under the bit logic. So, all three are very important in ladder logic programming. I hope you have understood the normally closed concept. I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel for more updates. Thank you.
Hello everyone, welcome to Automation Community. In this section, we are going to see how to do simulation in CX Programmer. So before entering into the topic, kindly like and subscribe our YouTube channel. So let's see how to do the simulation in CX Programmer. So let's open CX Programmer. So let's take one normally open contact. So I'm going to take one contact and I'm going to name this as with the address PB1 and the address is 0.00. So let's take one coil, give some address and name. Now the inputs are in left side and the output is in right side. How to connect this contact and motor means you can make use of this horizontal line. So just choose the horizontal line, click here, so it will make a path. So once the path is made, that's it in the first run. So just click escape. I'm deleting the extra line. Right. Now we have one normally open contact and one motor. So I'm going to turn on this motor using one open contact. So let's save the file. So I'll show you how to save the file. So already it is saved. So I'm going for the save as option. So in this you can give the name and you can see the programming file extension will be CXP, which is CX programmer, right? Just save it. So you can see the project name over here. Now let's see about the simulation. So in our landing page itself, you have an option called Work Online Simulator and we have a shortcut for that, Control Shift and W. So just click on that. So once you click, a program downloaded to PLC. That means what? In the simulation mode, it will assume that there will be a default PLC, like virtual PLC is there and we have to download the program from software to that PLC, right? So this is a virtual PLC kind of. So once it is entered into the simulation mode, you can see a rail becomes a green color over here. The rung over here is green color. That means what? It is in run mode. Right, I have told you in our previous section, right? In the simulation mode, we will be seeing a run mode. So in this, you can able to edit this input. So now this positive rail and this is negative rail. So positive rail is carrying a flow, the input flow, right? So this flow have to reach motor to turn on a motor. So how this will get to reach motor means we have to turn on this push button. Right. So I'm going to force this. So if you right click on this contact, there is an option called force. So in that force, just press on. So once you pressed on, you can see the flow entered into the switch and it reached our motor. So now the motor is on. So this green color implies that it is in on condition. Right. So the motor is on. If you want to turn off the motor, just make this to off. That's it. The motor is off. So like this only we have to do the simulation in CX Supervisor. And to get out of this simulation mode, you need to click on the same icon. So it came out of a simulation mode. So once you came out of the simulation mode and there is no green color flow over here. Again, if you enter, it will come again. Right? And also you can see in the title bar, you can see there is an option called running. You can able to change the input to see the change in output, right? So suppose just watch this running status. If I click here,
So it is entering into the stop mode and it came back to the normal programming mode. So now the program is in programming mode. Alright. So that's it about the simulation part in CX Supervisor. I'll meet you in the next session. Before that, like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about logic gates in CX Programmer. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So logic gates programming in CX Programmer. So let's see 3 logic gates in this section. One is AND, and another one is OR, and the next is NOT. So let's see about AND gate. We all know about the truth table, right? So this is the truth table of AND gate, and we are going to perform this logic in CX Programmer. So here we are having 2 inputs and 1 output. Correct? So in CX Programmer we have to use 2 inputs. Let's name that as in1 and in2 and output as out. So only 2 inputs and 1 output, and for this we have to use this for condition. If both the inputs are off, output should be off. If any one input is on, still output have to be in off condition, like that. So both the inputs are on, then only output have to be in on condition. So we'll see how to do this in the CX Programmer. So let's see about OR also, OR truth table also. OR is like opposite to AND. If any one input is on, output will be on. Correct? So NOT is having only one input, which means it's like a complement. 0 means 1, 1 means 0. That's it. So let's see AND gate in CX Programmer. So I'll create new project. So it's created. So as we have seen, we need 2 inputs, right? So I'm going to use normally open contact, and I'm naming this as in1. Sorry, this have to be addressed right. 0.00. Just click enter, and it is asking for the comment, and give this as in1. Click OK. And let's take one more input. So now we have to use one more input, no? That input where you are going to keep, whether in the same run or in the next run, and how you are going to connect these 2 inputs to perform the AND gate for that particular output. So think about the truth table now. If both the inputs are off, output have to be off. If both the inputs are on, output have to be on. Both the inputs must on. That means what? It should be in a series. See, you can confirm this statement with these 2 also. If any one is off, output have to be off. That means what? In the series, if any one input gone, you cannot get the output. So AND gate is nothing but a series of connecting 2 inputs to get the AND performance in output. Right? So let's see that. So I'm going to put the second input in series to perform the AND gate. I'm naming this as in2, and take a output and I'm giving an address and naming that as out. Right? Going to connect these this rung with horizontal line. Right? So just click on escape. Now both the inputs are connected in series with the output. So let's see how this is going to perform, whether we are going to get the result for AND gate or not. So I'm entering into the simulation mode. Right? Fine. So now the rail is active now. Now let's see the first condition 0, 0, 0. So 0, I'm not turning on the input, and same this also I'm not turning on. Output is also 0. So the first condition is true, right? I mean the first condition we have achieved it, right? 0, 0, 0. Let's take 0 as off condition and 1 is on condition. So both the inputs are off, output is off. What is the next one? 0, 1. So this, let it be, we are not going to disturb this first input. So let's turn on the second input. So second input is in on condition, but still output is off. So the second condition is also we have achieved. So 0, 1, 0. Correct? 0 means what? Off condition. So output is an off condition only, no? Yes. So what is our third condition? 1, 0. So first I'll turn off this. So what we have to turn on now? First input. Turn on. So now look at this 1, 0, 0. So the third condition is also true. Correct, na? Third condition is what? 1, 0, 0. Correct. What is the last one? 1, 1, 1. Now I'm going to turn on both the inputs. Let's see whether output is in on or off condition. So I'm going to turn on this, which is making my output to on. Correct. So my output is on for 1, 1 condition. So this is nothing but a AND gate. So while you are going to get the result for AND gate, you have to perform all 4 logic in one concept. It's not that each condition is having each rung and each line. I mean, there cannot be the different logic for this. This is the only concept for AND gate. So you have to put both the inputs in series to get the result. Understood? So let's turn off both. I'm going to the programming mode. So AND is done. So AND gate we have done it. Correct? So let's go for the next gate, which is nothing but OR gate. So OR gate is what? Any one input is on means output can be on. If both are off, then only output have to be off. So let's see how to do that. So I'm going to use same input. Okay. Now the question is how I'm going to connect, whether it is in a series or in some other way. So series I have already done. If I connect that in a series, it will become the AND gate. So what is OR? OR is like a option. This or this. Correct now? OR is like a option, this or this. So this or this means I can go for the parallel option. So what this parallel option will do? If any one input is on, output will be in on condition. So I'll give the same. Okay, I'm going to use a different output because already I have used 100.00 as one of the output. So I'll use 100.1 and name that as out 2, 1, because that is out, no? So now let's name this as out 1. Right? So I'm going to connect these two using the vertical line. Okay, so I'll do one thing. Just delete this. To get a parallel contact, make use of this one. Okay, there will be an option like putting single contact over here, and we can connect using the vertical line. So now you can make use of this option, new contact or. So if you click and keep it here, it will create a new contact. That's it. So immediately it will get connected. So you see, both are connected. Now you can put this here and you can connect as usual. Correct. So now it's done. So let's move on to the simulation mode. It is transferring and it is ready to use. Now OR gate is what? 0, 0, 0. The first condition is true. What is the next condition? 0, 1. So 0, 1. So what I'm going to do, I'm going to turn on this input. So I have used some different address. So no issues. This is not the same as IN2. So okay, let's do one thing. Let's go to our programming mode and change the address of this. I'm going to edit. So what I'm going to do, I'm giving 0.01. Right? So now this is the same address of this. Let's go to simulation mode. Now fine. 0, 0, 0. Now I'm going to do 0, 1. So this I'm not going to disturb, and I'm going to disturb this. On. So output is on. So this is our gate, right? You can see for the same 0 and 1 condition, this output is off. But our condition output is on. So let's turn off this and turn on the first one. 1, 0. So this is 1 and this is 0, but still output is in on condition only. Because 1, 0 is 1 in OR gate. Correct. What is the last one? 1, 1. So turn on this. Still this will be in on condition. So 1, 1, 1. So OR gate is done. Correct. So AND gate will also be having 1 for this condition. 1, 1. When both the inputs are on, output will be on. So that's it about AND and OR gate. And we have one more gate which is NOT. So NOT is having only input. If 0 means 1, 1 means 0. So how to perform this? Only one input. Let's take only one input, 0.00. Okay. So let's take one different output, 100.2. Okay, let's name this as out2. Okay. And connect. Right. Fine. So now what is our condition? 0 means 1. Correct. So let's move on to this. Now see, my output is 0. Sorry, my input is 0, but output is 0 only. But this is not my requirement, no. My requirement is what? 0 means output should be in on condition. So, but for normally open contact, I cannot get the condition. So what I have to do? I have to go to the programming mode and need to think about it. So normally open contact is not working for NOT gate. So what I can do? I can introduce this normally open contact. Instead of using normally open contact, I can use NC, normally closed contact. Give the same address. Just delete the normally open contact. Okay, fine. So now let's see, instead of normally open contact, I'm using normally closed contact. Let's go to the simulation mode. Right, we got a condition. You're not disturbed the switch. That means what? You have not forced the input, but still output is a non condition. That is the working of normally closed contact. if you are not doing anything, I mean if you are not disturbing the input, output remains in an on condition. If you disturb, if you change the state of that input, output will be off. If you see, if I am forcing that to on, what is happening? Output is off. Correct? So this is NOT gate. So this is AND, this is OR, and this is NOT. So I hope you have understood the basic logic gate concept. I will meet you in the next session. Before that, like and subscribe our YouTube channel. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about logic gates in CX programmer. So let's move on to the NOR gate. So this is the truth table for NOR gate. When both the inputs are off, output have to be on. So since we have solved NOT gate, you can get some idea for NOR. So in NOT gate, what happened when the input is off, output have to be on. So same like that, here also both the inputs are off, output have to be on. And see the fourth condition, when both the inputs are on, output have to be off. So from the first condition, you get to know you have to use a normally closed contact. And from the last condition, you can get to know both the outputs have to be normally closed and both have to be connected in series. So let's see that in CX programmer. So I'm going to use normally closed contact. Okay. So I'm putting the same NC in another nearby and giving the different address. And I'm getting an output. Okay. Right. Now connect using a horizontal line. Why I have put this as normally closed contact? Because when you are going for the online, you are not going to disturb the input, but output have to be on condition. So this is possible only with normally closed contact. Correct. See, I have not disturbed both, but output is on. So let's perform the last contact, so that last condition, so that you get to know why I have put it in a series instead of OR. So now I'm going to turn on. Correct. See output, what happened to output? Output is off. Right. Even if you just make this on again, off again, if you turn on any one input also, output is off. So check out the condition. 0, 1 is also 0. So the only on condition is 0, 0. So that's what we have used AND gate. So NOR is nothing but normally closed contacts have to be connected as AND gate. That's it. Simple, no? So 0, 0 means 1, 1, 1 means 0. And the remaining in between two conditions are also 0. That's what I have connected these two in series. Okay. So that's it about NOR. Let's move on to NAND. So NAND is just ulta to NOR, correct? So see, both are off means output have to be on. Okay, this is somehow similar to the NOR gate's first condition, right? Correct. Look at this, 0, 0, 1. Here also 0, 0, 1. But check out the second condition. 0, 1 is also 0, 1 here. 1, 0 is also 1 here. The only condition for NAND gate the output is 0 is both the condition have to be 1, 1. So, any one of means output can be on. What is this logic behind this? This is nothing but a OR, right? OR concept, no? Option. I have told about the word called option. So, option is what? Any one is on means fine. Here, both are off is also fine. Worst condition is both should not be in on condition, so that output have to be off, right? So here also I'm going to use normally closed contact only, but that will be in parallel. So I'll take new closed contact OR. So I'm putting over here 0.01. I'm giving a this. So let's take a coil and give some different address and connect everything in using a horizontal line. Correct? Fine. Let's move to the simulation mode. So now see, both are off. Output is on. Why I am telling both are off? Because I have not turned on the switch. I have not disturbed the switch, but output is in on condition. This is what our first condition, no? So let's check out the second condition. What is the second condition? 0, 1, 1. So 0, 1, 1, 1 means 0. I'm not going to disturb this, but I'm going to disturb this. 0, 1. So check out the output state, output condition. It remains on. Correct? So I'll make this to off again. Now 0, 1. Sorry, 1, 0. 1, 0. I'm going to disturb this. Look, my output is remains on. So if I turn on both the inputs, output is off. That's what the condition is, no? 1, 1, 0. So NAND is connecting to normally closed contact in OR option, and NOR is connecting to normally closed contact in AND condition. Understood? So that's it about NOR and NAND gate. I'll meet you in the next session. Before that, like and subscribe our YouTube channel for more updates. Thank you.
Hello everyone, welcome to Automation Community. In this section, we are going to see about logic gates. If you have not subscribed our channel, kindly subscribe our channel for more updates. So, in our previous session, we have seen the remaining logic gates in TIMX programmer. So, in this, we are going to see two. One is XOR, another one is XNOR, right? So, XOR gate, we have a truth table over here. So, if both the inputs are off, output is off. If any one input is on, output is on. But if both the inputs are on, output have to be in off condition. So, this is a bit complicated comparing to the previous logic gates. So, if both the inputs are off, output is off. So, in our previous gates, what we have come to the conclusion that by seeing the first condition, we will be getting the conclusion like whether we have to use, normally open contact or close contact, whether it is in a series or whether it is in a parallel. But here it is very bit difficult to understand how to put the contact first, whether normally open or normally closed. Correct? So just check it out here. If any one input is on, output is on. So this is something like, OR gate, right?
If both are off, output is off. If both are on, output is still in off condition. So with only two contacts, we cannot able to make this logic. But we have only two inputs only, no? So how to get that extra contact? So there is no need to use the extra contact. You can use this input 1 as normally open and also as normally closed. And same in 2 also, you can use in one place, you can make use of that as normally open. In another place, you can use that as normally closed. So you can change the the way of using the inputs, but it will be the same input only. There is no extra contacts, same input only, but different conditions. So let's see that in the programming software. So I'm using 0.00. Okay. So now I'm putting one normally closed contact and naming that as one more input. Okay. So connect an output. So just connect these two. So I'll just go for the simulation as of now. I'll just to explain. Right. So what it is telling? 0, 0. Output is 0. Have you got the first one? 0, 0. Output is 0. Correct. So let's perform this condition. Third one. 1, 0, 1. So what I'll do? 1, 0, 1. Anna. So I'm going to turn on this. 1, 0, 1. So the third condition is also coming. Correct. So 1, 0, 1. So let's perform the third one. Second one. 0, 1, 1. So let's see that 0, 1. 1 means I'm going to turn on this. So I have turned on this, but output remains off. But my condition have to be 1. So with this, I cannot perform the second condition and fourth condition. So what I have to do means, I have to make one parallel contact. I'll put here and name that as same as this. Understood? So see here, now first input is using as normally open condition and also as normally closed condition. Okay. So put one more normally open contact and name that as 0.01. So see here, this 0.01 is normally closed here but open here. This 0.00 is open here but closed here. I will go for the simulation. So it is not that we have used 4 inputs. See, I have used only 2 inputs. Input 1 and input 2. Correct? See, all the inputs are off condition. But look at my output. It is turning on. Output is turning on. So output have to be in off condition, right? So there is some mistake over here. So let's see what is that mistake. Okay. Now the input is coming from this location. See output, how output is on? From here and it is going through this location. The route it is taking, the rung, the power from positive rail is starting from I 0.0's normally closed contact and normally closed contact of I 0.01. So my output have to be in off condition, no? So the way of the order of putting the contact is wrong here. So what I have to do, instead of putting this, I'm putting it here. Okay, I'll do one thing. I'll just delete and add it again. I'll cut it. I'll paste it. Okay, we'll add instead of that. I'm putting 0.00 here and 0.01 is here. So now what will happen? Now the path it cannot take, the path it will not take from this location, correct? So let's see that. I'm going for the simulation mode. And now look at this, the output is in off condition. Correct, because the path is closed here. This is on, this is, this is normally closed contact, this is also normally closed contact, but the address is crisscross. This is 0.0 here, normally open, and this is closed. This is open here, this is closed here. If you interchange the order, output will be in on condition, correct? So 0, 0, 0 is done. Now 0, 1 should be 1. 0, 1. That means what? I'm not going to disturb the first input, but I'm going to disturb this input. So look, output is on on condition. How output is in on condition? Because I have turned off this I have turned on this. Since I have turned on this has to be on. Why this is turning on? See, I have not turned on this. Is it like that? No. See, this is normally open contact, right? This is normally closed contact. If I disturb this contact will also get disturbed because both are sharing the same address. You want to have a look means I'll do it again. Can you see this is also changing? Okay, let's turn on this. This will change. Understood? This is the working of normally closed contact. So the second condition is done, which is 0, 1 should be 1. 0, 1 should be 1. What is the next one? 1, 0, 1. So I'm just make this to off again. So now what is the condition? 1, 0. So I'm going to disturb the first switch. This one. Disturb this. Output is on because it is taking this route directly. So what is our last condition? 1, 1. So I'm going to turn on both this and this. So turn on, turn on. Output is off. That's it, no? So both are on, output is off. So that's it about XOR gate. Don't confuse why I have used 4 contacts here. I am using only 2 contacts. Address to address, but usage of contacts is different. At one place it is normally open, at one place it is normally closed. So that's it about an XOR gate. I hope you have understood the concept. If you like this video, kindly like and subscribe our YouTube channel for more updates. I'll meet you in the next session. Until then, bye. Hello everyone, welcome to Automation Community. In this section, we are going to see about latching. So before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So latching is one of the interesting topic in PLC programming. Let's see what is the logic behind this latching and what is the use of that and how to do that in the CS programmer. So I'll just take a help from one push button and one relay. So now I'm going to turn on a relay using this push button. So what is the function of push button? So once you press, it will make a contact. If you release the push button, it will break the contact, correct? So push button is like, while you press, your output will be on. If you release, output will be off. So if this is the working of push button, why in industries and in all automation industries, why people are using push button. So if you see, most of the input device, I mean as a switch, people will be using push button only. So there is a logic should be there, no, to make the output remains in on condition. So how come we can press the push button all the time to make the output? There should be some concept which is called as latching. So if you press the input, and even though if you release it, output will be in on condition only. So this is called as latching. So but how they are performing? How to get this concept done? Even though if I release the push button, how the output is remains in on condition. That's what we are going to see how to do that. So let's see, this is the start. Let's take this as a push button. So this is a push button and we have output here, which is a relay. Okay, let's take this L as positive rail and this N as negative rail. So positive supply is coming from push button and negative supply is there from relay. So to turn on the relay, we have to press this push button, and that's what we are pressing. And once you press it, your relay is in on condition. Correct? So now, if you release it, your output will go off. Correct? But if you turn on again, if you do the proper arrangement, if you do one parallel contact of relay in parallel to start button, I mean start push button, you can able to make the relay on even though start is not on. If you see the next slide, even though if you release, the output remains on using this. So how to do that, I'll see. So let's take one small example. Instead of relay, let's take you are going to turn on a motor using one push button. If you turn off that push button, your motor should be in on condition. So let's see how to do that. I'm going to take one push button 0.01 and I'm naming this as PB1. Let's take PB2. Okay. So I have one push button and I have one motor over here. That's it. Connect. So this is a normal one. One push button, one output. So let's go to the simulation mode. Right? Okay. So now I'm pushing the push button on and I'm releasing my hand. Output is off. So this is how actually the working of push button, right? How the push button works. If you press, it will contact. If you release, output is off. But my output have to be in on condition even though if I release push button. And that concept is called as latching. So latching nothing but making a parallel route. Okay, once your output is on, no, and using that turning on, you are using one more extra contact, and that contact is named as same as your output. I'll show you here. Going to give the same address of your output. See, this is programming. So it is not that you are using one more input as output. Not like that. Just a minute. I'll delete this. Okay. So look, I have one input only and one output only, but in your logic, you're using one contact and naming that as your output. Why I'm naming this as output? Because the output is going to turn on for some seconds, no? So in that some seconds, this coil will get turned on. Correct? So I'll show you in the simulation. Look, now push button is off, output is off. I'm going to turn on a push button, and before that check out this also. 100.00 is off because this is same as this, no? correct? So your output. So I'm going to turn on a push button. I'm going to press it. Your output is on. Because of your output is on, since this contact is also sharing the same address of your output, this is also on. Okay, so you just turn off your input and your output is still on because of this contact. So this coil is called as a latched contact. Okay, or seal-in contact. We also call this a seal-in contact. That means you are taking the same ID, I mean same address of the output and putting that in parallel to the input. So if you, since you have put that as in parallel, even though your input, the main input is off, your output contact will give you a power supply to turn on your output coil. So this is called as latching. So just check out here, this is input, this is output contact, no? So if you see the PPT, you can see here relay on and NO contact of relay. Okay, so now look, we have a push button and now we have a NO contact of relay which is connected in parallel with the switch, push button. Okay, so once you press the switch, your relay will on, no? And that relay memory contact is also on, right? So now what will happen? Power is coming from this route and power is also coming from this route also. So if you cut down this route, what will happen? Power will take this route. That's it, no? Simple. See, if you have removed the contact, see, it is taking this route so that the relay is in on condition. So this is called as latching. So this is very, very important in the PLC programming. I hope you have understood this logic. So I'll meet you in the next session. Before that, like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about unlatching. Before entering into the topic, kindly like and subscribe our YouTube channel. So, latching we have seen, now this is unlatching. So, you have turned on a motor using a latching concept and push button. Okay. So, now how you are going to turn off a motor? So, once it is latched means you have to unlatch it somewhere. Let's see how to do that. So unlatching have to be with some other input. Okay. So if you have a start push button, you should also have a stop push button. This is mandatory because without another push button, we cannot able to turn off a motor. Right. So see, look out this. We have a start push button and we have a parallel contact of the relay, normally open contact of the relay because to latch the output. Now, by using one more input, we are going to unlatch it. Okay. So, let's see. So, whenever you are turning on, your coil will also get turned on and your contact will also get turned on. So, if you release it, what will happen? Your output remains in on condition. Right. So, if you turn off the output, you have to open this contact. You have to open this contact so that your relay will be in off condition. Correct. But see, there is one important logic over here. Here, stop push button is used as normally closed contact. Look, normally open contact is used for start push button. But stop push button is used as normally closed contact. Why? Why means initially it have to allow the power. It should allow the flow from L to N, positive rail to negative rail, it should allow first. So for that only we are using normally closed contact. If you are using normally open contact, then that will be act like one more start push button. So that's not our requirement, no. Initially it should allow, if any case you have to press it so that it will break the contact. So all emergency stop will be the normally closed contact. Even in metro escalators and all, if you have seen, you can find one red color button in between the escalator. So that is for the emergency stop, and that contact will be a normally closed contact. So let's see how to do that in the CX programmer. So I have a push button, first push button, and output is on. This is the latching concept. No, so I am putting one more normally closed contact. I am naming that as one more push button. Okay. So let's go for the simulation mode. Right. So now I'm going to turn on the push button. Output is on. If you turn off, output is still on. So this is latching. So once you have turned on a motor using a push button, so your motor is doing some function, pumping water or whatever some process is doing. Okay, after some time your process is done, so you have to turn off the motor. So what you will do, you have to turn on this so that your motor will get off. So this is unlatching, seal out. So you are doing the sealing in and this is sealing out. To break the contact, we have to use a normally closed contact. Correct? So to make a contact means you have to put that in parallel. To break the contact means you have to put that in the series. Right? So this is latching and unlatching. So like this only, they have put it in the PPT. See here, latching. First, if you press, initially these two will be open, this will be closed. If you press, this will also get pressed and power is flowing. If you release the start push button, power is still flowing because it is taking this route. If you want to turn off, you have to break this, so that what will happen? Your output will also off. Understood? So that's it about the unlatching concept. So if you like this video, kindly like and subscribe our YouTube channel for more updates. I'll meet you in the next session. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see some example for latching and unlatching concepts using CX programmer. So for latching, let's see the example 1. So when the start push button is pressed, pump 1 is on. If it turns off, the push button is off, it should remain in the on condition. Okay, so there is one input and one output over here. If the push button is pressed, output has to on. If it is off, if push button is off, it is released, means still it has to be in on condition. Okay, then when push button 2 is pressed, the pump 2 should on and remains on even push button 2 is released. Okay, the third one is, this is the single problem. So when start push button 3 is pressed, pump 3 is on until it get released, until it not released. See, there is a difference between the first two statement and this one. The third push button is pressed, pump 3 is on until it get released, until it not released. The next one is when stop push button is pressed, pump 1 should off. So we have turned on the pump 1 in the first first statement, no?
that have to be off when PB4 is pressed. Then PB5 is pressed, pump 2 is off. Okay, so let's try to solve this problem. So first, let's take whenever you are having logic like this, you have to write down what all the inputs and outputs you are having actually. So let's take a count: PB1, PB2, PB3, 4 and 5. So we have a 5 inputs here and all 5 are push buttons. Fine. And we have pump 1, 2, 3, 4, not 4. 1, 2, 3. So we have 3 outputs. So totally our IO list is 8. 5 inputs and 3 outputs. Got it? So let's move on to our CX programmer and try to solve the problem. So in the example, they have given the addresses 0.01, 00, 01, 02 and this is 1.00, 1.01. So we'll write the same address. Fine. 0.00 and they have given the name as PB1. PB1. Got it? So first input is done. I'm just adding the second input 0.01 and the address is PB2. Okay, fine. And the third one 0.02 PB3. Got it? And the fourth one is 1.00 and the name is PB4. So I'll just put here. Later we'll see where to add that. And the name is PB5. So 5 inputs are added. Correct. So now we have to add outputs. So let's take motor 1 and what address they have given? 5.00. Okay. So 5.00 is pump 1, not motor. Pump 1. So pump 1 and I'm putting one more coil which is for pump 2. Okay, now I'm putting the third one which is 5.02 and that is pump 3. Fine, right. So now we have 5 inputs and 3 outputs. So what is our first statement? Whenever push button 1 is pressed, pump 1 have to on. So what we have to do? It is pressed, it should on. So it will be the normally open contact. So I'm connecting directly like this. Got it? I'm connecting directly like this. And now what they have added? And remains on even if push button is released. So what I'll do? I'll put one parallel normally open contact here and the address should be same as pump. This is called as latching. We have seen already. So latching is done. First is done. And what they have given next, when PB2 is pressed, pump 2 should on and it should remains on even though if it is released. So it's same like the previous one, no? So add the horizontal line to make a connection and add one parallel contact to the PB2 and give the same address as pump 2. Got it? Done. What they have given as third, when PB3 is pressed, pump 3 is on until PB3 is not released. So let's read the statement one more time. It looks confusing, right? When PB3 is pressed, pump 3 is on until PB3 is not released. So if you release the PB3, this fellow should be off. Correct? If you release this will be off.
If you are not released, it will be in on condition. That means what? They don't want a latching. Correct? So if you press, pump 3 will be on. If you release, it will be off. See here what they have given, on until PB3 is not released. So if it is released, it will be off. Right? So we have to read the statement properly to understand what they have given. See, it is not similar to the previous one. So previous one they were asking if PB2 is off, still output have to be on, like that they have given. But here they have given like this. See, PB3 is on, this will be on. If it is off, it will be off. So there is no need of latching it. Got it? So let's move on to the fourth one. When stop push button is pressed, pump 1 should off. See, pump 1 is here and my stop push button, this fellow is here. So I want to turn off this pump 1 using this contact. So what I have to do? I have to put it here, but that should be a normally closed contact. So let's do one thing. Just press escape, add this and name that as same PB4. So it should be a normally closed contact, no? I hope you have remembered in the previous session I have explained about this emergency. Always emergency stop, always emergency stop or whatever stop push button, always it should be a normally closed contact. Got it? And the last one is when stop push button is PB5 is pressed, pump 2 is off. So they are talking about pump 2 now. So they are going to turn off pump 2 using this PB5. So what I'll do, I'll add one normally closed contact here and name that as 1.01, which is push button 5. Done? That's it. That's it. This is latching, this is latching and this is unlatching. Very simple, no? So let's save the file and go for the simulation. Give this as 3. Let's turn on a simulation. So what I'm going to do, pump 1 is going to turn on using push button 1. So I'll press the button, pump 1 is on. If I release the button, still pump 1 is on. Okay. Next, I'm going to turn on a pump 2 using the next push button. Yes, it's on. If you turn off, my pump 2 is still on. When I'm turning on push button 3, pump 3 is on. If I turn off, it will off. That's it. Correct. Now, when pump 1 have to be off means you have to turn on this PB4. So it is off. When you turn on this PB5, your pump 2 is also off. Got it? So like this only. See again, this push button again, if you release, your output will not be in on condition because once it is unlatched means unlatched. Again, if you want to turn on, you have to turn on this. The this is not this one. See, since it is a simulation, I can able to force this output. So I'm going to turn on this. That's it. Got it? So very simple. So that's it about the example 1. I'll meet you in the next session. Before that, like and subscribe our channel for updates. Thank you. When start push button 6 is pressed, one trolley, a transfer trolley is moved even if PB6 is released. Transfer trolley is stopped when detected by stop sensor or if one more push button, stop push button is pressed. So let's see that with the picture. We have a trolley here, which is going to move if I press PB6. PB6 is the push button. So if I press and release, still it will be moving. Okay, that is the latching. Again, when PB7 or stop sensor comes, this fellow has to stop moving. Look at this. Let's keep on moving, 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 moving. And once this fellow is on or stop push button is pressed, take this as an emergency stop. In between also you can stop, or else it will stop automatically when it goes to the stop sensor. So let's do this in the CX programmer. So I'll take PB6 and the address they have given is 7.00. Okay, 7.00. 7.00 as PB6. So my output is 5.03. 5.03 as trolley. Got it? So this have to be on when push button is on. Even it has to be on when the push button is in off condition. So I'll take one parallel contact and give the same address as my trolley. So understood? So done. Then latching is done. When it has to be off, whether a stop push button, which is 7.2, PB7 or the sensor. So 7.2. Okay, 7.2. Fine. I'll give that as 7.2. I'll give some other address which is taken already by PB7. I'll give 7.3 and this is a sensor. That's it. So what will happen? It is like any one comes, it should off. So let's go for the simulation. So here we have two unlatched contact. Any one is on, trolley will off. So I'm turning on a push button, trolley is on. If you turn off the push button, trolley is still on. If this on or this on, if this or this, any one on, it will break the contact so that trolley will get off. On, the trolley is off. Correct? So make this off again. Again turn on a push button. Off it. Then trolley is on. Now I am going to stop the trolley using sensor. If sensor is on, trolley is off. That's it, guys. So this is latching and this is unlatching. I hope you have understood latching and unlatching concepts in this example. I'll meet you in the next session. Before that, like and subscribe our channel for updates. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about set and reset concept in CX Programmer. So, what is this set and reset? In our previous session, we have seen latching and unlatching concept, right? So, for all latching, we have to latch a contact in parallel to the input. Right, I hope you have remembered the example we have seen. So I'll show you one more time. So I'm taking one push button and naming that as 0.00. and I have one output here. Let's name that as 100.0. So I'm connecting these two. And to latch this, I have a parallel contact here. So I'm naming that as 100.0. So what will happen? If I press this, it will make a contact. If I release, it will be still in on condition through this route. Correct. So this is what latching is, right? So imagine you are having a big project, and in that project you have multiple latching concept. Okay, so for everything you have to connect a parallel contact to this, and again you have to put an unlatch contact to turn off that particular output. So this is bit complex, right? So to reduce this complex, we have a separate block for this, and that is called as set. So latching you can also do with the set concept also, and unlatching can be do with reset concept. So set is like once you have set it, it will be in on condition until you reset it, right? So let's see how to do that. So I'm going to take one more, let's take the same 0.00 and name that as one of the push button. So now I'm going to turn on a motor using a set coil, right? So how I'm going to use, get the set coil means take a block. So there is a new PLC instruction and the shortcut is I. Suppose after keeping here you press I. It will take you to the instruction list. So from this, whatever you want, you can choose. So I'll go with the option here, click on that, and now you need to get the set instruction. So go for details. If you don't know the keyword for reset or the particular number for the reset, you can go for the details and get find instruction. So in the find instruction, go to sequence output, and there you can find set over here, set. So click on that and click OK. And it is asking for the operand. So which one you want to set? Which output you want to set? That address you have to give here. So just type, you are going to set one of the coil called 100.1. So just click OK. So now what is happening here is, we are going to set a coil named 100.01. See, instead of latching, instead of putting one parallel contact here, you can make use of this set instructions to set a coil. So let's go for simulation. I'm going to turn on this. So see, 100.001 is on. 100.01 is on. So if you turn off, it's still in on condition. It's same as this latching, right? Now how to turn off this? You can make use of a reset coil. So whenever you are introducing a set coil, you have to reset it someplace. So what I'm going to do, I'm going to use this input, 10.01. Let's name this as PB2. And take the same block and type RS reset. So if you don't know what have to type for reset means, same you can go for detail, find instruction, sequence output, and there you can find the reset or SET, right? And here also which coil you want to reset. So this I have set it no, so I'm going to use the same address 100.01 and I'm going to reset that. So just connect with horizontal lines. Done. So let's go for simulation. So I'm going to turn on this. My output is on. See, 100.01 is on. Here also it will turn on because both are same address, no? That's what. And you can turn off. See, still it is in on condition. So once the purpose of 100.01 is done, you have to reset it, no? So I'm using one more coil, one more contact to reset it. That's it. See, it's off. I'm turning off this. That's it. I'll repeat. You're going to set it. It turns 1. Can you see the status of 100.01? It's 1. Turn off this and turn on the reset coil to reset the 100.01 output. That's it. So this is set and reset instruction, and we have plenty of applications for set and reset. So it will reduce your ladder size. The size of the program can be reduced with the help of such instructions. So I hope you have understood set and reset concept. So I'll meet you in the next section. Before that, please like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see about rising edge and falling edge. So what is rising edge instruction and how we are going to use? So let's see about that. So rising edge instruction is a pulse input, and even falling edge is also a pulse input instruction. So it is different from the normal input contact. So what pulse means? Pulse means a single shot. So normal input will be continuously giving an input, right? So pulse input will be one single pulse it will give. After that, it will go off. So let's see in the programming. So I'm going to take normally open contact and go for the detail option. Just give the first give the address of that. I'm going to give 00 and okay, just cancel this and go for detail. In this detail, you can see the default option chosen is none. So go for up. So what is this up condition means? Whenever this particular input is going from off to on condition, it will give one pulse. So since it is from off to on, 0 to 1, so this is called as rising edge. It will give pulse at the rising edge. So let's choose up and go for OK. Right? So yes. So since it is the pulse, you cannot able to see in normal coil. So I'll show you that also. Since it is a pulse, you cannot able to see the output here. But with the help of set instruction, you can able to see the output. So I'm going to set one more output with the pulse input. So let's take this as motor 1. That's it. So let's go for simulation mode. So just to watch both 100.00 and 100.01, I'm going to turn on this 0.00. That's it. The bit got set. Even 100.00 was also on for a very minute second, but we couldn't able to see. Since I have used the set coil here, pulse is setting this particular output. So if you turn off also, it will be on because it is a set coil. Okay, so since it is giving one single shot when it goes from off to on condition, this is called as rising edge. So what will be the falling edge? So falling edge will be when it is going from on to off condition. So let's take the same input and go for detail and choose down. Go for OK now. So when 0.0 is going from on to off condition, it will give one pulse, right? So I'll use one more. Instead of set, we'll reset that particular coil. 100.00. Sorry, 01. That's it. Just connect these two. Go for simulation mode. So I'm turning on this. The coil got set. Correct. If you turn off this, it will reset that particular coil. So this is rising edge. This is falling edge. So if you are confusing why I'm using the same input means, better I'll use one more input here, 0.01, and I'm using that as falling edge. So you can see there is a symbol. It is going up. That means this is the rising edge. It is coming down. This is the falling edge. Right? So both are different inputs now. That's it. Let's turn on this. On. The coil got set. If we turn off, fine. Right? Now, this is one more input I'm going to turn on. So it is giving a pulse which is resetting this. Okay, this is a pulse which will on when it going to off condition. So this is on, no. So it will not having any influence now. Now I'm going to turn off this. It will reset the coil. So this is rising edge and this is falling edge. So these two inputs are at most used with set and reset coil, or to reset some timer or counter and all. You cannot use that with normal output because you couldn't able to see, and you cannot able to utilize this pulse with normal coil. You can be used that with set and reset condition. So I hope you have understand rising edge and falling edge concept. I'll meet you in the next session. Before that, kindly like and subscribe our channel for more updates. Thank you.
Hello everyone, welcome to Automation Community. In this session, we are going to see about differentiate up and differentiate down. So let's see what is that. So just go to the new PLC instruction, go to details and go for find instruction. In the sequence output, you can find differentiate up and differentiate down. So this is similar to rising edge and falling edge. So let's see what is the difference. The way of using is different. Okay. So in the rising edge, what we have done is, we'll just cancel that. So for the rising edge, we will be using the new contact, and we were choosing this, right? So this is the rising edge. But differentiate up performs the same function as rising edge, but it will looks like a block. So here you can see differentiate up. Just click on that and give which coil you want to turn on. Okay, so I'm just choosing one of the output and I'm clicking enter. So now just connect these two. And for this, instead of this, I'm using a normal contact. Just click escape, delete, and add a normal contact. So 0.00. Right. So now how to use this block? Now, if you turn on
this 100.00 which you have mentioned in differentiate up, no, that will give one pulse. So the address you are using inside this differentiate up will give one pulse. So how to make use of that means just take one more contact and give the addresses 100.0. So this output is nothing but now you can see once I have added the 100.00 as contact, you can see one extra vertical line over here which implies it is a rising edge. Fine. So I'll add one set coil here, set 100.01. Now I'm connecting. So let's go for the simulation. So whenever I'm pressing 0.00, it will it will give continuous pulse to this differentiate up, but differentiate up function acts like a rising edge. So it will give one single pulse to the output. So using that output, I'm going to set one more output. See, look at this. I'm going to turn on. So I'm turning on 0.00 only, but it is setting 100.01 through 100.00. So even if I turn off, nothing. It will remain on because I have used the set function. So this is similar to the rising edge, right? So we have one more block which is differentiate down. So I'll use one more input contact and I'm going to use differentiate down. Sequence output, in that we have a differentiate down. So which one you want to set in this? I'm going to use one more output here. Just connect and go for simulation mode. Okay, before entering into the simulation, I have to utilize this bit, no? So just get out from the simulation mode. Now we'll add one contact and give the name as 100.02. Now I'll add one coil. Let's take one more set alarm or reset you can do. Set you have done for 100.01, no? So we'll reset that. Reset 100.01. Connect. So see here, this is differentiate up. So you can see one vertical line while it is going up. Here you can see the vertical line is shifted to the right side since it is used as differentiate down, which is nothing but like falling edge. So the falling edge will give one pulse. So let's see that. So I'm turning on. So it got set. I'm turning on 0.00. Continuously input will be coming, but this block will give one pulse to 100.00. Using that one pulse, I'm setting one more output here. Now we'll turn on this one. So while I'm turning on, nothing is happening to 100.02 because this is used inside differentiate down. So let's see, I'm going to turn off this. That time it is giving one single pulse to 100.02. With that pulse, I'm resetting the set coil. So I'll repeat. I'm turning on one input. Our output got set due to this differentiate up pulse. Just turn off this. Now, using this differentiate down, I'm going to reset this. So differentiate down is like when it will give pulse while on to off condition. So I'm turning on, okay. So nothing is happening, correct? So if you turn off, it will give one pulse. With that pulse, I'm going to reset. See, this is in on condition. No, now I'm going to turn off. So it is making off. So reset happened. So this is differentiate up and differentiate down. This is similar to rising edge and falling edge, but rising edge and falling edge instruction will be like in contacts. This will be like a block. Using this address, you can use it as contact also. So that's it about differentiate up and differentiate down. I hope you have enjoyed this video. If you really like this video, kindly like and subscribe our YouTube channel. I'll meet you in the next session. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about key instruction in CX Programmer. Before entering into the topic, please like and subscribe our channel for more updates. So what is this keep instruction and how it looks like? So I'm going to take this new instruction block, go to detail, go to find instruction, and you can find keep instruction in the sequence output. Just click on that and it is asking for the operands. So I'm giving 100 pound viewers one of the coil. So now look at this block. So keep and it is asking for one bit address output coil and it is having a 2 input over here. So keep instruction is like a set instruction. But the difference is keep instruction is also having a reset function. So instead of using set and reset as a two different blocks, you can use this keep block so that you can reset and set using the same block. Let's see how to do that. I'm taking one input, which is 0.0, and let's give a switch one. So I'm going to connect with one of the input, right? So this is for set. The first input asking for keep is a set. So what this implies? What is this means? Just go for the simulation. It will throw an error. Since while debugging, it is showing there is an error because it is not connected. This particular input is not connected. So I'm connecting one more input here and just connect using the horizontal line. Right. So now go for online. So one to set and one more input to reset. So instead of using set and reset block separately, you can make use of this keep block. So I'm going to turn on 0.000, yeah, 0.00. Input got set. The output got set. 100.00 is set. You turn off this. This will remain in the on condition because it is performing like a set coil. Okay. Now to reset this, you can use one more input and turn on. It will reset your coil. So combination of set and reset blocks is a keep block. So one for set, one for reset. So using this block, you can utilize one particular coil. If you want, you can use multiple keep instruction and putting one coil. So that's it about the keep instruction. So I'll meet you in the next session. Before that, like and subscribe our YouTube channel. Thank you.
Hello everyone, welcome to Automation Community. In this session, we are going to see about interlocking. Before entering into the topic, kindly like and subscribe our channel for more updates. So interlocking is one of the important concept in PLC programming. Without interlocking, we cannot able to write a program for the big projects. So let's see what is this interlocking. So interlocking is a feature that makes the state of two mechanism or function mutually dependent. So mutually dependent, two functions are mutually dependent. What does that mean? If one function is happening, another function should not happen. If the second one is happening, this should not happen. So mainly in big projects, they will be using interlock for the alarms. For example, if any alarm is there, you cannot able to turn on the output. So you can able to turn off the output if any alarm comes. Like that, you can make a concept according to the requirement. So let's see one example here. You have a 3 inputs and 3 outputs. See, if this particular output, if the particular output name 0.0 should be in on condition means, it should be on means, this particular output should be in off condition. See, Q0.1 should be in off condition. Same like 0.1 have to be in on condition means this particular output should be in off condition. Like that, we can write a interlocking concept. So let's write one small example in CX programmer. You have a 2 inputs. So I'll name this input as 1.00 and I'm naming that as switch 1. Okay, and we have our output here and I'm naming that as motor 1. Connect these two. So whenever you are turning on a turning on the switch 1, output should be in on condition. Let's take one more input, 1.01, name that as switch 2 and connect one output here, 100.01, which is M2. So 2 motor, 2 switch. So my requirement is, due to overload, I cannot run both the motor at the same time. So if M1 is on, M2 should be in off condition. Or M1 is in on condition, M2 should not be on. Or M2 is in on condition, M1 should not be on. So like that, you can write the interlock using the address of outputs. Say I'm putting a normally closed contact and I'm giving the M2 address. So what will happen now? Let's see that. I'm putting 100.00, which is M1, right? So let's go for the simulation mode. Let's see what is happening there. Right. So someone is turning on switch 1. So your first motor is running. So motor 1 is running. So someone want to run M2 motor also, but they are not knowing M1 motor is running. So they just turn on the input. So what is happening? Even though they are turning on the switch 2, it is not turning on the M2 because M1 is already in a running condition. So since M1 is in running condition, we have used the normally closed contact of M1 here. It's not allowing the power to flow from left to right, so that M2 is in off condition. Same like turn off both. Someone has turned on M2 first. So they are in requirement of this motor, so they have turned on. And without the knowledge, someone is trying to turn on M1 now. Now look at that. M1 is not turning on because M2 is already running condition. Understood the concept? So this is called as interlocking. So this concept is interlocking. And you can introduce one more input here. If that input is on,
this should not happen. Like that you can make a interlock. So I'm writing 11.0 is one of the input. So if that is on, this should not happen, means you can write a normally closed contact of that particular input in series with the output. See, someone is using this 11.00. Maybe let's take, this is one of the alarm conditions. So alarm is there. In that condition, someone is trying to turn on motor 1. So they are trying to turn on a switch. Your switch is on, but since the alarm is there, it is not allowing the motor to be in on condition. So this is interlocking. So interlocking is a very important concept. So like this, you can explore some examples. So I hope you have understood the interlocking concept. I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this section, we are going to see instruction for interlocking in CX programmer. So we have an instruction called IL and ILC in CX programmer. So let's see what is that. So it is like a range. So I'll take CX programmer's help to explain this. So I'm having one input here. And to take a IL instruction, you just type IL here, and yeah, the interlock comes. So this is for safety precaution. See, your program is having, imagine you are having, 100 or 200 lines of, runs you are having in your project, right? So in some emergency cases or in any critical condition, you want to turn off multiple outputs, means what you can do, you have to turn off each and everything separately. Correct. To turn off output, there will be some condition and you have to turn off everything. So instead of that, if you can put that in one range, in one of the, area, and if in some emergency cases, you can turn off only one condition. You can make only one condition to turn off everything. Okay, so that's what the instruction for interlock will help. So I have an interlock, instruction here, and I have a one input condition. All right. So I'm going to write my program from here. So I have one switch, and I have a motor here. So like this, you may have more motors. Imagine like that. For example, only I'm taking only one. But if you want, we can take two also. So I have one more switch. And I have one more output here. So these two motors are in some critical area. In emergency cases, I have to turn off both immediately. So that's what I'm going to put these two motors in the interlock area. So this is for starting of interlock, and this is to clear the interlock. ILC means interlock clear. IL is interlock, ILC is interlock. IL is interlock, ILC is interlock clear. So connect this with a run. That's it. So interlock clear, you got it. All right. So just go online. So let's turn on your output. The power is flowing, but your output is not turned on. Alright, can you see the difference? The circle is not on because M1 is not on. So turn on this. M2 is also not on. But if you put some other, I'll add the same input of which one. And oh, I have given the same name for this. I'm going to have one output here. 1, 3. Okay. So now let's go online. This is after the interlock area. Okay. This motor 3 is not in the interlock area. So now turn on this. And your motor 3 is running. But for the same input, your motor 2 is not running. Why? Because the interlock area is off. The condition I have given, the condition 0.00, I have given as an interlock input, no. So since it is off, you couldn't be able to perform these two outputs. So now if I'm turning on, so automatically my output is on. See, if you turn on the switch 1, now your output is on. So like some emergency cases, you are turning off. You are turning off only the interlock input, but see, look at this, M1 and M2, both are off. Even though the input is in on condition, your output is in off condition only. It is on, but the output is off because interlock is turned off. See, if you again turn on your interlock, both the outputs will be in on condition. So this is how you can protect your devices in emergency cases. So CX programmer is having the interlock, IL and ILC instruction for, this feature it will give. So you can make use of it to protect your devices in critical conditions. So I hope you have understood this interlock and interlock clear. So I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel for more videos and updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about timers. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So timers is one of the important concept in PLC. Even you can find the timer application in our home appliances also. For example, take an induction stove or automatic washing machine, or even in television or even in TV remote, you can find the timer features. So what is the working of timer in the induction stove? You can put that into the, if you're cooking something and you have to give a time delay so that after some time it should automatically turn off. So you can set a timer and after that particular time duration, automatically it will get turned off. So same like in washing machine also, you can set a timer for the whole operation. So for example, you can set a timer for 30 minutes, and when you press the start button, the timer will get start. So after in this 30 minutes, this washing, the working is completely splitted and it will be done before this 30 minutes. So even in TV also, you can use timer to put a TV on sleep mode. So like that, in home appliances also, we can find the working of and the usage of timers. So, but in industries, timers are mandatory. To write a logic for the big machines, timers are mandatory. It is used to create a time duration or time delay between two events. So let's see what is this timer. So timers in PLC are used to create a time delay between two events. So it will help the programmer to write a logic to turn off or on the equipments automatically with some other event. So if this happen, the next step have to be turn on automatically, means you can make use of the timer. So that's it. Types of timers here. So on delay timer, off delay timer, and retentive timers. So what is on delay timer? So the name itself implies that it is creating a time delay to turn on a process. For example, you're turning on a switch for the motor, but you don't want your motor to turn on immediately, but after 30 or 40 seconds. So in between this, you are turning on after 40 seconds only your motor have to turn on, means you can make use of this on delay timer. So if you put a on delay timer in between the switch and the motor, what will happen? When you turn on the switch, automatically timer will turn on. So timer will start counting like 0, 1, 2, 3 like that, and it will reach up to 40 seconds. After 40 seconds, it will give one trigger to the motor so that motor will get turned on. So this is on delay timer. And what may be the off delay timer? Yes, obviously it is used to give the time delay to turn on a output device or whatever you want to turn off, you can turn off. So how it will work? Let's take the same example. You have a switch, you have a motor. You are turning on the switch, your motor is running, fine. But you are going to turn off the switch, but you don't want your motor to turn off immediately, but after some time. So in this case, what you can do, you can make use of the off delay timer, and you can utilize the features of timer off delay, and you can turn off the motor after some seconds. So that is timer off delay. So what is this retentive? So the word retentive means it retains. So I'll just go back to on delay and off delay timer. So these two timers are non-retentive timers. So what is this non-retentive means? For example, you're turning on the switch and you have a motor over there, and in between you have a timer on. So turning on the switch, a timer started running and started counting from 0 to 40 seconds. So in between you are turning off your switch. What will happen means your timer will go back to 0 and timer will also get off. Timer will go off and the timer will go back to 0. Again, if you turn on a switch, it will start counting from 0 only. So it will not start counting with where it stops. So those type of timers are called as retentive, non-retentive, and retentive timers can able to retain the value. So anyhow, I'm going to explain this non-retentive and retentive concept using CX programmer. Okay, that time I hope you will get more clarity on that, right? So I'll meet you in the next session with what are the types of timers we are going to use in CX programmer. So before that, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. Kindly like and subscribe our channel for more updates. So in this session, we are going to see about timers in CX programmer. So we have more number of timer types in CX programmer. Let's see one by one. So first we are going to see this TIM and TIMX. So these two timers are non-retentive timers. So non-retentive timers means, I'll take an example and I'll show that in the CX programmer. So there is a concept called time delay. So what is the time delay means? How many seconds you are going to give. For example, we usually talk in seconds, right? See, I have in the previous session I have explained like 40 seconds duration like that. But timers is having the time delay variable that will be like, for example, you cannot give 40 seconds as 40 directly. So it will be like 100 milliseconds, 10 milliseconds timer. So according to that, you need to calculate, correct? So for example, if you want to see this TIM and TIMX is a 100 milliseconds timer. That means what? To run at 10 seconds, you have to give the value as 100. Okay, for 20 seconds, you need to give the value as 200 because the set value unit, the time delay unit is 100 milliseconds. So it is not 1 second timer, it is 100 milliseconds. So according to this, you need to give the process, I mean the time duration, how much duration you want to give. That is called as set value. Okay, and in this TIM is BCD type timer and TIMX is binary type timer. Okay, both work same, but just the data type is different. That's it. So here the N is telling that it is a timer number. So the timer number will be starting from 000 to 4095, right? And what is this S? S is the set value. So here only you will be giving how long your timer have to be run, the time duration. So for PCD type timer, you have a range, and for the binary type timer, you have another range. Look at this, you have a range. So let's see how to use this timer in the CX programmer. So I have created a new project, and I'm going to get on contact, and I'm going to name that as okay. Fine. So I'm going to just type I, I is the instruction. So this is the shortcut. Is the shortcut for I. If you want to get the new instruction, you can go for just click on here and type I, or go here and choose the instruction. Go to detail, find instruction. There is a timer here. Okay. So in this, timers and counters are there. So I'm going to use this TIM first. So once you use the TIM, you can see this is a 100 milliseconds timer. This is a BCD type. Right. So just choose this, and the timer number you have to give. So the timer number I'm just going to give a 0 and go for OK. And now this is showing red color, right? So there is something have to be added with this. That's what it is showing, like error. So just go again, edit. So in this edit, what we have to give? We have to give the time delay, right? So I'm giving hash. So hash, this is the format to give the time, the duration, the time delay. What is the time delay you want to give? You can give here. So hash, I want to run this timer for 10 seconds. Since it is a 100 milliseconds timer, I'm going to give 100. So 100 into 100 milliseconds is 10 milliseconds. So just click OK. See, now that red color is gone, right? So let's connect the contact and timer. And now I have to get the feedback of this timer, right? So example, you are going to turn on this output motor, right? You are going to turn on the motor after 10 seconds. This is the switch and this is the motor. Okay. So how I am going to take the feedback of this timer? Yes, you can make use of the contact itself. So the contact name should be the timer name, T0. Okay. Just click and connect. Right. So that's it. So what will happen when you turn on the switch? It will take 10 seconds to turn on a motor, right? So let's turn on the switch. Go for the simulation mode. So it is entering into the simulation mode. So let's turn on the switch. So the timer started running. Can you see the timer is running over here? So after 10 seconds, the output is on. So when you turn off the switch, what will happen? Your timer is off, your output is also off. Okay, so here the hash 100 is the set value, and this timer will be like a decrementing from higher range to lower range it will run. So from 100 to 0 it will go. Okay, so it will start at like count down from 10, 9, 8, 7 like that it will count. So I'll do it again. I'm going to turn on. See, it started running, it started counting down. So once it is reaching 0, motor will on. Got it? That's it. So one more thing. What if I turn off the input in between? Let's see what will happen. It started running. So I'm going to turn off. Timer is off and it go back to the previous value. So that's what it is called as non-retentive timer. So let's add one more type, which is this TIMX binary type. Let's see that also. So I'm going to have one more input here, 0.01, and let's take TIMX. So go to detail, go to, if you know the short name of that, you can choose, else go for this. Get help from this, no issues. You can go for TIMX. Where it is? Here it is. So this X means there is a binary type timer. Nothing, it's same. It looks like, it works like same, but the value, how the value is taking is different. So let's set for this also 100. This is also 100 milliseconds timer. You can see here 100 milliseconds timer. And one thing is, there you have used a hash, no? Here you have to use this AND symbol. AND 100. That's it. That is the difference. The format of giving the set value is different. Okay. Now let's connect. Right. And you have to get the feedback for that. So it's same like that. So I'm going to give T1. So it's taking the timer contact. I need to give the same name as timer. Okay, this is the timer number now, and I'm giving the same timer number here. Let's take one more new output and name that output as another motor 1. Okay, all right. Let's go for the online simulation. So look, here also the value is changed to 100. So let's turn on this. So it started counting. So after 10 seconds, automatically 100 turn on. All right. So let's make this input as same as this input, so that you can see both the timers are in on condition. So I'm going to delete this. Right. So both are having the same input. You see both the timers will turn on, and at the same time it will turn on both the motors. So this is a 100 millisecond timer. So I'm going to turn on this. Yeah, it started running. So you can see this is off, this is off. After 10 seconds, this will on, this will on. That's it. So both the motors are on. So this is the non-retentive type timer, and it is having the 100 milliseconds time delay duration. So in the number of seconds, what is the set value you have to give is, you have to calculate and give. For 10 seconds, I'm giving 100 here. Like that you have to calculate. So 100 into 100 milliseconds is 10 milliseconds. So that's it guys. I hope you have understand these two timer types. So I'll meet you in the next session with another two timer types in CX Programmer. Before that, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about another two timer instruction in CX programmer. And these two timers are ultra high speed timers because the time delay unit is 1 millisecond. Alright, so these two timers are non-retentive timers. And here you can see the timer number value should be in between these two range, and the set value for normal BCD type timer is this one, and for binary is this one. Alright. So let's move on to the CX programmer and see how to do that. I'm going to take the same example. So TIMHH. So let's search for that TIMHH. So I'm just pressed I. So TIMHH. Alright, we got that. Then I'm giving the timer name as 0 and I'm giving the time duration as 10,000. Why I'm giving 10,000 here means this is 1 millisecond timer. So 1 millisecond timer. I'm going to use the timer for 10 seconds. So I'm giving 10,000 here. So the 10,000 into 1 millisecond is 10 seconds. Click enter. So there is an error here. So let's see what is that. So let's take one more instruction also. So while compiling, we get to know what is that error. So for timer, so TIHH, this one. Yeah, this one only. This is a 1 millisecond timer, ultra high speed. So click OK and give the timer address as 1. And set value will give. I'm going to give here is, yeah. So that's it. So we'll delete and add it again. TIM. TMHH or TIMHH, giving 0, and the value is hash 10,000. Okay, let's compare and see. Out of range. Okay, let's see what is the range we can give for this. Yeah, the range is 0000 to 9999. So that's what it is taking an error. So the set value have to be in range. So I'll do one thing. So for 9 seconds, I'm giving like this. So what will happen? 999 into 1 millisecond is 9.99 seconds. So yeah, now it is accepting, right? So while compiling, we get to know what is the error we are getting. Then go for the simulation mode. I'm using the same example as the previous one, okay? So now we'll turn on. So this will run for 9 seconds and this will run for 10 seconds. So let's turn on these two. That's it. So after 10 seconds, automatically both the motors will get turned on. That's it. Right. So turn off this and we'll turn off in between. It's running. Both the timers are running. I'm turning off. So what is happening? It will go back to the previous one. It is also going back to the previous one. That's what these timers are called as non-retentive timers. So I'll meet you in the next session with a retentive timer concept. And before that, kindly like and subscribe our YouTube channel for more updates. Thank you.
Hello everyone, welcome to Automation Community. In this session, we are going to see about some timer example. So before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So without any delay, we'll move on to the example. So example 1. When switch 1 is pressed, lamp 1 is on for 5 seconds and lamp 2 is on after 5 seconds. So here we have one input and two outputs. One has to turn on when the switch is immediately on. See, here they have given the word called for. For means what? It should only on for 5 seconds. After that, it has to off. And lamp 2 is on after 5 seconds of switch 1. So let's go to the CX programmer. So I have taken one switch here. So we'll add the lamp 1 first. Lamp 1. Right? So this has to on immediately when the switch is on. Alright. So let's take the same input again and we'll turn on a timer. This is an on delay timer and I'm naming the timer as 0 and we'll give the time duration of 5 seconds. Since it is a 100 milliseconds timer, I have to give 50 here so that I will get 5 seconds. So alright, we got it. So connect the contact and the timer. Now this particular output have to turn on after 5 seconds. So what does that mean? With the timer, with the use of timer contact, I need to turn off this lamp 1. So what I can do, I can use the normally closed contact of our timer contact. That's it. So what will happen when the switch is on, immediately lamp will on. But the timer is also on. So after 5 seconds, the timer output will turn on. Using that particular output, I'm going to turn off lamp 1. Understood? So now what we have to do? So after timer has turned on, we have to turn on the lamp 2. That's it. Very simple timer example. So by using timer, we are going to turn on one input and turn off another, not input, output. By using a timer, we are going to turn on one of the output and turning off another output, turning on and turning off. Understood? So let's go for the simulation mode. So this lamp 1 is going to on only for 5 seconds and this is going to on after 5 seconds. So let's turn on our input. So this is immediately on. Okay. So this is on and after 5 seconds it will go off and a lamp 2 is going to turn on after the 5 seconds. Alright. So if you turn off, so everything will go off. So I'll repeat. I'm going to turn on this. This is going to on for 5 seconds and this is going to on after 5 seconds. So I hope you have understood this example. I'll meet you in the next session with another example. Thank you.
Hello everyone, welcome to Automation Community. In this section, we are going to see about another two types of timers in CX Programmer, that is TIMH and TIMHX. These two timers are high-speed timers and it is having a time delay unit of 10 milliseconds. This is similar to the previous two timers, but here the time delay unit is 10 milliseconds. So the instruction will be looks like this: TIMH and TIMHX. So X is for binary and this is BCD. So let's see how to do that in the CX Programmer. So here I have used the same example what we have seen for the previous two timers. So let's go for the new instruction, dtime, find instruction and go to timer, TIMH. Can you see here? This is the 10 milliseconds timer and these two are high speed timers. So this is the BCD type. Click OK and give a timer address. I'm going to give a 0. And it is asking for set value. We'll give that and we'll take the BCD type also. TIMHX. That's it. And give the timer number. I'm giving us 1 and give time duration as for 10 seconds. I want to run the timer. So how many seconds I have to give here? Since it is a 10 milliseconds, I have to give 1000. So that 1000 into 10 milliseconds is 10 seconds. So this is a small conversion you have to do. So that's it. So same like here also you need to give the value. So I'm using hash here and same 1000 I'm giving. So that's it. So what will happen after 10 seconds, this output will on, and after 10 seconds, this output will turn on. Okay. So let's go online and check. So these two timers are also non-retentive timers. So in between, if you turn on the input, your set value will go back to the previous one. I mean, 1000 BCD. The value will retain 1000 BCD. These two are also a decrementing timer, so it will start counting down. So let's see that. I'm going to turn on an input. Look at this 1000 and it is started reducing. Both are started reducing and after 10 seconds motor will turn on. I'm using a single input to turn on both the timers. That's it. Okay. So just turn off. Now we'll turn off the contact in between. So turn on. The timer is running. Turn off in between. What is happening? Both the timers are off and it will go back to the original value. So it is not returning where it stopped. So that's what it is called as non-retentive timers. So this is the high-speed timers in Omron and the unit is 10 milliseconds time delay, right? So I'm giving 1000 as for 10 seconds. So you need to take a timer feedback, same as the previous one. Contact you have taken and you have given the timer address. Alright. So I hope you have understood these two timer instruction. I'll meet you in the next session with another two timer instruction in CX Programmer. Before that, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about retentive timers. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So in CX Programmer, we have two type of retentive timers. So one is TTIM and TTIMX. So both works same, but this is a binary type timer and that is a binary type timer. So here is the timer number and the timer number must be between these value. And we have a set value range here. So for BCD, this is the range, and for binary, this is the range. Okay. So without any time delay, we'll go to the CX programmer and see how to work with these two timers. So TTIM and TTIMX. Let's open a same example. So I have here TTIM. This is called as totalizing timer. So retentive timers are called as totalizing timers here. So click OK and give the timer name here 0. And here you can give the set value directly here, or you can give OK and you can edit there also. So I'm going to give here for this time. I'm just giving 100. Right. So once you click on this, you are getting a one more input here. So all retentive timers are having a reset option. So a timer is having a two inputs are there. One is for turning on the timer and another one is for resetting the timer. So what I'll do, I'll just add one more input here to reset the timer. So 0.01. So all retentive timers will be having a reset option. So go for this. So I'll edit this. Alright. So let's go online and check this BCD type first. Then we will go for binary type. So let's turn on this. So after 10 seconds, your output is on. Right. So this totalizing timer is like counting from low value to higher value. Okay. So why it is counting from lower value to higher value, I tell you. See, even though if you turn off the timer value, your output is not turning off. That is a feature of totalizing timer. So you have to use the reset option to turn off. See, once you turn on the reset input, even your set value is going to 0 and your motor is also off. So that's the working of retentive timer in Omron. So I'll repeat again. I'm going to turn on this. Okay, so after a time delay, your output is on. So you are turning off your input. So in the previous 6 timers, in the previous session, we have seen the types of timers. So in those timers, if you turn off the input, your output will also go off. But in retentive type of timer, the totalizing timer in CX programmer will not work like the same. So you have to use one more input to reset this. It is like a set. So once the timer is turned on means it is like a set coil, and after that obviously you have to use the reset option to reset the timer and also your output. So I'm going to turn on this to reset. That's it. We have done the reset. So one more thing. So let it be running. We'll turn off in between. So it started increasing. I'm going to turn off in between. So look at this. What is happening? Your value is retains. Right? So previously what will happen? It will go back to the original value. So now where you got stopped, it is returning over there. So let's turn on again. And it started running from the place where it left. Correct? So that's what it is, retaining the value. No, that's what it is called as retentive timer. So let's add that binary type also. 0.00 TIMX timer 1, and I'm giving the value same as that. That's it. Okay, and I'll have, this is also having 2 legs, so I'm adding the same reset coil input and I'm connecting it. Right, and we will have one more input to turn on an output. Right, so it's connected. So let's compile this. So we have an error. So what is this error? Look at this, overlapping runs. So in Omron, if you are using a timer, that should be in one run only. You cannot connect one more output along with this. Look at this. This is having at 0th run, and the motor is at next run, and this is at second run, and this have to be in the next run. So just cut and paste it in the next run. That's it. Now we'll compile. So there is no error for online. Alright. So turn on. Both the timers are started running. If you turn off in between, both are holding the value. Correct? And if you turn on again, it will start from there. And once the time delay is done, it will turn on a motor. So the first timer is turning on this motor, and the second timer is turning on the another motor. See, I have not turned on this. So look at this. This output is not turned on because I have used some other input. Instead of using the timer number, I have used some other input. That's what this is not turned on. Okay. So if you turn on the reset, what will happen? So if you turn on the reset, your timer is getting reset. So we'll edit this one. Okay. So let's run again. Turning on, both are running. So after that, motor 1 and motor both will go turned on. See, it's turned on. See, now the input is on. Okay, if I reset, what will happen? It got reset. Okay, but you just turn it off. That's it. Again, it will get turned on. The timer will again get turned on because your input is still in an on condition. So I'll repeat again. Both the outputs are on. No. So now before turning off the input, I'm going to reset. So now the reset bit is on. So your set value is going back to the previous original value. Okay, the starting value. So now you are going to turn off your reset. Since your input is in on condition, it started running. The timer is again start. So this is the working of retentive timers, and all retentive timers should have a reset input. I hope you have understand the concept. I'll meet you in the next session with another interesting topic. So before that, kindly like and subscribe our YouTube channel for more updates. I'll meet you in the next section. Thank you.
Hello everyone, welcome to Automation Community. In this session, we are going to see another example timer using CX Programmer. So let's move on to the example. So we have a water sprinkler system. Fine. So water sprinkler system starts to work when when temperature sends signal to it. Okay. So when a temperature sensor is giving a signal, a water sprinkler system has to start. So how it is going to start means first it has to sprinkle water for grass, then flowers, then trees. So it will be like a plants. So first grass, then plants, then trees. And they have the respective time delay. So for grass for 5 seconds and for flowers or plants it is 10 seconds and again for trees again 10 seconds. So one by one it has to sprinkle the water. So let's try to solve that in the CX Programmer. So I'll delete the timer. Alright. So now take this input as our temperature sensor. So when the temperature sensor is on, so let's edit the comment. So this is my temperature sensor. So when my temperature sensor is on, I'm going to turn on a sprinkling for grass first. Correct? So it has to sprinkle grass for 5 seconds. So I'm turning on one coil is a grass. So let's edit and give the name as grass. You're going to open one solenoid valve. So let's take it as grass valve. Okay. Done. So after that, what will happen? So grass valve have to be turned off after 5 seconds. Correct. So how to turn off a grass valve after 5 seconds? So we have to introduce a timer here. So let's take the same input and put it here. And in this place, I am going to introduce my timer. So let's introduce the same on delay timer TIM 0 and how much seconds they have given? It is 5 seconds. So I'm going to give 50 here. Alright. So now my grass valve had to turn off after 5 seconds, right? So what I have to do? I have to turn off this using timer contact. So I'm going to use normally closed contact of my timer. Alright. So what will happen now? After some time, after 5 seconds, automatically grass valve have to be off. So after this, what should happen? Next for flowers, it has to turn on for 10 seconds. So what I'll do, how I can take the feedback like this is after 5 seconds. So I can take help from the same timer, right? So I'm going to use same contact of timer to turn on a valve for flower. So let's turn on one more output and I'm naming that as flower valve. I'm just giving the comment for our understanding. That's it. So flower valve is going to turn on after 5 seconds. And when is going to turn off? After 10 seconds. Correct. So flower valve have to be on only for 10 seconds. So I'm going to introduce one more timer here. And that timer have to turn on when this timer ends. So what I'm going to do, I'm going to use the same address of timer to turn on the second timer. TIMX, and I'm going to give a different name, and this has to be 100 because 10 seconds.
timer 2. Alright. So let's connect these. So now you get to know how to turn off flower valve. How? By using the timer 2. So to turn off means obviously we will be using normally closed contact, right? So yes. So after 5 seconds automatically flower valve will be on, and after 10 seconds automatically it will get turned off. Now we have one more work. What is that? After this 10 seconds I have to turn on valve for 3. So let's connect the timer address here to turn on my third timer, TIM2, and this is also 10 seconds. So connect. It's done, it's connected. So I have to use this timer address to turn on the valve for 3. That's it. So connect these two, and when it has to off? It has to off when this timer ends. Correct? So I'm going to put here as T3, T2. That's it. So let's check for any error. So we don't have any error. Go for online. So we'll turn on. Imagine temperature sensor is on. So immediately grass valve is on. So after 5 seconds what will happen? Grass valve will be off and flower valve will be on. See, 3 valve is in off condition. So after 10 seconds flower valve will be off and 3 valve is on. So after 10 seconds 3 valve will again off. So that's it. So if you want to repeat this, you have to turn off the temperature sensor and again you have to turn on. Alright. That's it. So this is how you need to use the timers in your logic. So after 10 seconds 3 valve is off. So again if you want you can turn on, turn off and turn on. So automatically the cycle has to repeat means you need to use set and reset instruction for making this loop. Okay, so once the the flow is done, if you want to repeat means you have to reset and you have to turn on. Okay, for that you can make use of set and reset instructions. So try by yourself. So I'll meet you in the next session with another interesting topic. So before winding up the session, kindly like and subscribe our YouTube channel. Thank you. Welcome to Automation Community. In this session, we are going to see one more example in timer. So without any delay, let's move on to the topic. So when switch 2 is pressed, after 5 seconds, lamp 1 is on. So this is a sequence. Okay, first you have to press the switch 2. Once you press the switch 2, after 5 seconds, lamp 1 has to on. After 5 seconds of lamp 1 on, we have to turn on lamp 2. And after 5 seconds of lamp 2 on, we have to turn on lamp 3 and lamp 4. So when after the 5 seconds of lamp 3 and lamp 4 on, we have to turn off all the lamps. Okay, this is the sequence. One by one, it has to happen. So let's go to the CX programmer. Add a switch 1 first. Switch 1. Alright. So after 5 seconds, I have to turn on my lamp. I have to turn on one of the lamp. So what I have to do, so immediately for the first time itself, we'll turn on a timer here. And the seconds they have given is 5. So let's connect our input. So whenever you are turning on the input, your timer will get turned on. So when the timer is turning the output on after 5 seconds, will turn on the lamp 1. Lamp 1. Alright. So connect. So what will happen now? Whenever you are press this, timer will start counting down, and once it is reached, the 5 seconds, lamp 1 will be on. So in the meantime, what we have to do? When this timer is getting on, in the same time we have to turn on, the timer output is on, right? In the same time we have to turn on one more timer. So let's make use of the same contact and we'll give this as timer 1. Okay. So I'm going to turn on one more timer here. TIMX and TIM, and this timer is timer 1, and I'm giving the same 50. This is timer 2. So what this timer will do? It is going to turn on my next output. So I'll give T1, and what is my next output? Lamp 2. Alright. So connect. So what do I have to do? In the meantime, we have to turn on one more timer. So turn on lamp 3 and 4. Connect. And take this contact, timer 3, and this is going to turn on 2 outputs. Lamp 4. And I have to edit this 100.03, which is my lamp 3. That's it. Connect. So whenever the third timer is on, both of my output will turn on. So in the meantime, we have to turn on one more timer. So let's turn on the timer, and I'm going to name the timer as 4, and after 5 seconds only it will be turning on. So I'm going to name this as timer 4. So what is the use of this timer? The last timer have to turn off all your outputs. So make use of a normally closed contact and put it over here. This is your P4. So lamp 1 will off. Lamp 2 will also off. And both of your lamp 3 and lamp 4 both will get off. Okay, I'll put it separately for this. That's it. So let's compile. So we don't have any errors. Let's go to the simulation mode. Got it. So let's turn on a switch. So after 5 seconds only my lamp 1 will on. After 5 seconds lamp 2 will on. After 5 seconds lamp 3 and 4 parallelly will on, and lamp timer 4 will turn off all the lamps. See, here I have done a mistake. What is that mistake? I have used normally closed contact of T2. So it should not be like this. This is T2, no? This have to be normally open contact. T2. That's it. And I have to delete this one. That's it. It have to be a normally open contact. So that when that on, then lamp 3 and lamp 4 will on. So let's turn on this. So immediately all my, the timer gets started, but lamp and all is in off condition. So after 5 seconds lamp 1 is on. Now lamp 2 is on. Now lamp 3 and lamp 4 will turn on. After 5 seconds all lamp will go off. See, lamp 4 off, 3 off, 2 off and 1 off. That's it. So now turn off your input. I'm going to repeat the same thing. It's turn on. So all our outputs are initially off condition. See, now lamp 1 on. Next lamp 2. After 5 seconds lamp 2 will on. Now after 5 seconds lamp 3 and 4 will on. After 5 seconds all our output will go off. That's it. So this is another example in timer. So I hope you have understood the concept. I'll meet you in the next session. Thank you. Welcome to Automation Community. Kindly like and subscribe our YouTube channel for more updates and videos. So in this session, we are going to see about counters. So counters are also very important instruction in PLC. So what is the working of counter and what is actually counter? So counter in PLC are used to do a count operation. So if you want to count some value, you can make use of the counter instruction. It is used to increment or decrement any event. Okay, it will count. Like the best example I can tell is while packaging, okay, in the industry, maybe in the food industry or in some production industry, they want to count the number of components passed in the conveyor. Okay, so in industry, obviously everything is automatic, right? In a minute, there may be 1,000 of components is crossing the crossing in the conveyor. So you want to make a count how much it has crossed. So in one day or in 1 hour or 1 minute or in 1 second, how many the components or what may be the package or whatever it may be, their product, how much it is crossed. If you want to have a count means you can make use of the counter instruction in PLC. So imagine there is a packaging industry, okay, and they have a sensor in the conveyor line. So in the conveyor line, the package, maybe let's take, food, food package, some fruits or food, okay. So it is coming in the pack. So each and every pack is coming in the line. So they want to counter how much package has crossed the conveyor. So they will be putting one sensor in the conveyor. So whenever the package is crossing, no, the sensor is giving one pulse input to the counter. So counter is the virtual device in the PLC inspection. So it will be automatically count whenever the sensor is giving the input. No, so automatically it will count. For example, per day you have a limit. So this much package only has to cross. Let's take an example, 100 pack. So once 100 pack has crossed, it have to create one alarm, or it have to turn on some tower lamp. Kind of means you can make use of such instruction. So that is the use of counters in the industry. And we have two types of counters, actually three types of counters. One is up counter and down counter and up down counter. So up counter is like counting from 0 to the upper value. In the example I have given, 100 package means it will start from 0, 1, 2, 3, like that it will count. So down counter is like you will be setting 100 already. Okay, and it will be calculating, okay, one package has crossed means it will down the counter. So 100 is changed to 99. And another 2 to 3 parcel has crossed means it will reduce from 99 to 97 or 96. Like that, down counter will work. And what is this up down counter means? The function of both up counter and down counter will be working in up down counter. And I'll just explain up down counter in the CX supervisor in the next session. So kindly like and subscribe our YouTube videos for updates. So I'll meet you in the next session with up counter and up down counter. Thank you. Hello everyone, welcome to Automation Community. Kindly like and subscribe our YouTube channel for more updates and videos. So in this session, we are going to see how to use the up counter in CX Programmer. So let's take instruction and go for detail, find instruction, and there you can find counter. So CNT, this is our counter. CNT counter, let's take that, and it is asking for counter number and the remaining variables. So I'm giving the counter number as C0. Okay, you can, no need of C, you can give directly C and give OK. So once you have given, you need to set the value. So how much count you want to make? So let's take the example. The parcel have to move in a conveyor, no? So you will be having a sensor. So let's add one sensor here. Sensor. So whenever the sensor is giving an input, the counter has to increment. So let's take how much count we can do. Let's take 5. If once the 5 parcel crossed, I have to turn on alarm. So hash, just type hash and 5. That's it. So like this only you have to give the set value. So for every 5 count, it will give the signal. So that signal how you can take means that feedback from the counter you can take with same normal how we can take it for the timer, same like you can give. You need to give the timer, counter's address, and you have to give as normally open contact. So when this contact will turn on, whenever the 5 value is reached, it will be on. So I'm going to turn on one alarm bit or buzzer bit. Let's take as a buzzer output. Alright. So now if you see the counter, we have one more input here. So what does that input mean? That is for the reset. So counter is having the reset input. So all counters will get reset to start from beginning. See, after 5 count, what will happen? The counter output will be in on condition only. Correct. So counter, once the output is on means it will be on only. So how you are going to turn off? So you have to reset the counter. So let's compile. So let's go online. So there is a 5 count, right? So let's the conveyor is on. Imagine the conveyor is on and one parcel is going to cross. So I'm turning on one input, which imagine this is a sensor. The sensor is giving one input. So let's see the counter, its value is reduced to 4. So for it was 5, now it is 4. So turn off it. So again one parcel comes, it is turning on. So one more parcel. So 3 parcel has crossed. Okay. So now the 4th one. So now the 5th one. The 5th one is going to cross. So once the 5th one is crossed, you can see the output is on. The counter's output is on. Look, the buzzer output is on. So it will be like an indication, right? So now what happens if the 6th parcel comes? Nothing is happening. See, it is not at all taking. Because once the limit is reached, so the counter will not respond to your sensor. Okay, I'm turning on, nothing is happening. So what you have to do? You have to reset the counter. So you have to reset it. Reset. So that's it. Once you have pressed the reset, it will same as the previous, like the fresh one. Again, you have to start. So second parcel is happening. It's crossed. Okay. So now, there's some cases you want to start from beginning. So you have to start from beginning. You don't want the 2 parcel as a count. So you have to start from the beginning, means you can make use of the reset bit to start fresh. That's it. So in between, if you want to reset that counter, you can make use of the reset bit. I hope you have understand this counter concept. I'll meet you in the next session with up-down counter concept. So before winding up, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see how to use up-down counter in CX programmer. So let's take one empty instruction. Go to details, find instruction. So here we are having CNTR. So up down counter is called as reversible counter in Omron. Okay, so click OK, and you need to give the timer name. So I'm giving the timer number as 5, and what is the count limit? So I'm giving 3. Click OK. So the block is ready. So if you see, this block is having 3 inputs. So one is for up, one is for down, and another one is for reset. So the perfect example to understand this up down counter is, car parking. So if you want to know how much car has present inside the parking slot, means you can make use of this counter concept. How? So I'll explain that. So up counter is what you will be incrementing. So if you want to count how many car is entering, so that place is called incrementing, or that is called as up counter. Okay. So while entering area, while entry point, you can keep one sensor to sense, okay, the vehicle is crossing. So this is one count. Like that, you can give one pulse to the counter. So like that, I'm going to add one sensor here. So that is the entry sensor. Entry point sensor. So this, what is the working of this sensor? It will give one pulse if it detect a car is or a vehicle is passing. Okay. So this is entry point sensor. So whenever this sensor is giving an input, what will happen? The counter is increment. Okay, one car has passed, second car, third car, like that it will count. Alright. So next we have one more sensor at the exit. So what is the use of this sensor? It will count. Okay, the car has passed means it will give one pulse, and that pulse is given to the down counter of this reversible counter. So what will happen? If the value, the total number of car present inside is 2, means if this sensor is giving an 1 input, and the total number of car inside the parking slot will become 1. So that's what it will decrement the count. So I'm giving this as exit point sensor. And we have one more reset switch, right? So this is the reset switch, and I should have one more contact for counter number. So I have to delete this counter. So because my counter is 3005, all right. So I have a buzzer out. So buzzer out is to know the limit has crossed. So one difference you can find between this up down counter is an up counter means, see, for up down counter, when the limit is crossed, then only it will give the buzzer out. So I'll show you. So but in up counter, whenever the value is 3, and if we reach 3, it will give the buzzer out. But here, once the limit is crossed, then only it will give the buzzer out. So I'll just explain here with in the simulation mode, so that you can understand better. So imagine there is no car inside the parking slot. Okay. Now one car is entering. So the let's see, this value is the number of car present inside. All right. Now, so one more car is entering. Now the total number of car inside the parking slot is 2. Okay. So and after some time, one car is exiting. It's going outside. So this sensor is giving pulse to the counter. So the value becomes 1. So the total number of car present inside is 1 now. Again, one more car is entering. One more car is also entering. So now let's see, there is 3 cars inside, but output has not turned on yet. But if the 4th car is trying to enter, it will buzzer out. Okay. That's the difference between up counter and this up down counter. So for the up counter concept, CNR, what happens? CNT, in CNT what happened? When the 3 reach, then only it will give the output. But here it will have to cross the limit. Alright. So now there is limit reached. So when the limit is reached, you can find this is 0. It is not that there is no car inside. There is a limit has reached, so it cannot show the value over here. Okay, now what happened? Now one car is going outside. So you can see the value here. Now one more car is also going outside. So now there is only one car is inside, but you cannot see that. See, this is for our understanding. I have told this is number of car inside. But once the limit is reached and when you start counting down, the value will be 1 plus. So there is only one car inside, but since due to this is the reversible counter, we have counters 2 here. Alright. So now one more car is entering. So we have 2 cars inside. And yeah, we have reached the limit, right? And you want to start from beginning means obviously you have to give the reset. So once you have done the reset, everything you can start from first. So 1, 2, and 3. Once the limit is reached, that value will go to 0. That's it. Okay, so this is the working of up-down counter. So I'll meet you in the next session with some example in up-down counter. So kindly like and subscribe our YouTube channel for more updates and videos. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about counter reset instruction. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So in our previous sessions, we have seen about counters and the types. Now we have one more instruction in the counter which is used to reset the counter instruction that we have used in the program. So this instruction is not only to reset the counter but also a timer. So let's see how to use this. Go to details, find instruction, and here you can see timer bar counter, and this is the counter reset instruction, reset timer or counter. So I'll take this instruction and it's asking for the range from where to where you want to reset. That is the requirement for this counter. So what you can do, you can add some counters in your project. Okay, for example, I'll just add some counter in our project. Because without using the counter, what is the purpose of resetting it? So I'm using CNT and I'm giving the name as C0, and this is the reset value, the preset value. So I'm giving some 2, click OK. So one counter is added. I'm just giving input to that. It would be switch 1. And let's add one more input for the second counter. So for example, I'm adding 2 counters. Alright. So take one more counter here and name that is C1, and I'm giving the range of some 3 or 4. Okay, let it be.
we have to type C and T. I have missed out to type the instruction in the previous block. Now I'm giving the counter name as C1 and I'm giving the preset value as 3. Alright, done. Connect now. So now we'll add one reset input to this. And connect to the reset input. So we cannot give this as a blank input. So it should be the reset. I mean, we have to connect some contact to this. And I'm using the same input for reset to the second counter also. So now connect. So now let's compile it. I'll just show you first. Now I'm using two counters in the program, right? So I'll be incrementing the first counter and I will be incrementing the second counter. And what I have to do, I have to use this button to reset this counter and this counter. Suppose instead of this input, if I'm using some other input for this, let's take instead of this, I'm using one more input, which is reset 2. Okay. So in this case, what will happen? I need to reset the counter 0 with this first reset and counter 1 with the second reset, right? For example, I will turn on. So if I want to reset, I have to turn on this. So the counter got reset, okay. The same thing for this also, I have to use separate reset input for all counters. So each counter is having different reset bit, right? So previously I have added the same bit, but we cannot assure that it always we can use the same reset bit. There may be some conditions, okay? But if you are using the reset instruction of counter, that is like a one general reset. What and all range you are giving in the reset counter block, it will reset all the counters. So let's see how to do that. So you can get the reset counter block here. So let's go for the find instruction, go for the timer bar counter, and this is CNR, which is reset timer bar counter. So take that, just give the range. Okay. So what is this range means? So you have to give the timer or counter address. So from where to where you want to reset. So in our project, I have used only two counters. So what I'm going to do means I'm just giving C0 and up to C1. Suppose if you are using 50 counters in your project means in which range you want to reset. For example, 10 to 20 you want to make it as a reset means you can use that range. So for example, only I'm taking this only two counters. So I'm just going for OK, right? And for this I supposed to have one input which is a condition to reset. So I'm giving this as a master reset. Master. So this is a master reset. Alright. So give and connect to the block. So once you are connected, it's ready to use. Alright. So just go for compile and we don't have any errors. So just go online. So this is like a master reset of what and all range you have given in the reset counter block. So let's just increase this counter value. Just increase the second counter value also. So I'm not going to use the respective reset bit. Alright. So I'm going to use one master reset bit. So let's do one thing. Let's turn on the counter. It's reached the set limit. So it has reached and it has not reached. So let it increase one more. Okay. Alright, this is okay. This is also reached. So now without using this reset and reset 2, I'm going to reset these two counters using this instruction. So this is the master reset. So if you turn on, both the counters will get reset. Okay. So this is how it will be working.
So this is the master reset instruction of counter. So this is like in some emergency cases, or you want to reset all the counters you have used in the program. Obviously we will be following some sequence, right? C0 will be the first counter, like that. You should follow some sequence. So in which sequence you want to reset means you can give the range here, so that it will reset the counter. Alright, so just use this, and you can take some example and you can practice this instruction. I hope you have understood this concept. I'll meet you in the next session. Before that, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about example for counter instruction in CX programmer. So let's see example 1. You can see the image here, and we have a conveyor. Okay, this is the conveyor, and some objects is moving from this side, from top to down. So it's moving like this. Okay, and to detect the object, we have a sensor here. So let's read the question here. Object moving in the conveyor have to be counted and stopped the conveyor when 5 boxes has crossed. Okay, the boxes will be moving in the conveyor. The counter has to start. So when 5 boxes has reached, 5 boxes has crossed, we have to stop the conveyor. Alright. So manual reset option is possible by using reset PB, and here there is a push button to reset the counter, and indicator lamp has to turn on when conveyor gets stopped. So we have one more output here which will get turned on if the conveyor gets stopped. It's like an indication that conveyor has stopped, or 5 components or the boxes has crossed. Alright, so this is the sensor used to detect the object. Okay, so we have one input. Yeah, actually we have two inputs. One is this sensor, both are same. This one and this one, both are same. It's like a through beam. And, using the light source, we will be sensing the object. Okay, and we have one more input which is the reset. And here we have two outputs. One is our conveyor, and another one is this one, lamp or indicator. All right. So let's see the program in CX supervisor or CX programmer. Fine. So let's take one of the input, which is our, the sensor, the component present sensor. So I'm going to name that as 0.00, which is my, component. It may be the sensor which is detecting the object. So let's take it as light sensor. Fine. So whenever the light sensor is on, I have to count. I have to start counting now. So I'm using up counter. And what is the preset value they have given? 5 boxes. I have to type #5. All right. So connect, and we have a reset option. No, one reset push button is there, and I'm going to name that as reset PB. So connect. So connected. Now we have a conveyor which is actually running. So let's take one. Imagine in that question, add one of the start input. Okay, we have one more input, because to start the conveyor you should have some input. So let's take some start switches there for a conveyor, and you have a conveyor here. Okay, conveyor belt is there, and you're connecting these two. So the conveyor will be turning on whenever the input is on. Okay, and let's rename this. Start switch. All right, and you have a one more output, which is our lamp indicator. So whenever lamp indicator should turn on when this 5 count reached. So how to take that 5 count reached? So for that we have to use the counter instructions output. Just type C0. When the counter will turn on? Once the preset value 5 has reached. So that time it will turn on. So lamp will off. So let's see up to this. There is an error. Let's see what is the error. Overlapping runs. Yeah. So what does this mean? Counter is also a output instruction, and this conveyor is also output instruction. So you cannot connect two output instruction in one network. So I'll take this to new network. So delete this. Right, now if you compile, there is no error. Go for the simulation mode. Okay, so now the conveyor is on. Okay, now one box is crossing, so it started counting. Okay, so two boxes, second box is also crossing. Okay, okay, now second box, now the third box, now the fourth one. So whenever the box is crossing, it will give just a pulse. Now the fifth one. So fifth one has crossed. So what will happen? The lamp is getting on because I have used the counter's output. But the conveyor has to stop, no? So for that what we have to do? We have to use the normally closed contact of counter. See, I am putting over here. That's it. See, our conveyor has stopped. Lamp is on. Let the switch be in on condition only. No issues. So now if you reset the counter, what will happen? It will go back as previous one. See, the conveyor is on now. The lamp is off now. So again, the first object is crossing. The second object is also crossing. So it will take it as a pulse. Okay. So third one, fourth one, and the fifth one. Once the fifth one is crossed, lamp is on, conveyor is off. So until the reset, it will be like this only. Okay. So this is how you need to use the up counter. So I hope you have understood this example. So only one extra thing I have added here is one start switch for running this conveyor. To turn on the conveyor, I used one more input. Alright. So I hope you have understood this example in CX programmer. I'll meet you in the next session with another example for counter. Before winding up the session, kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about counter example in CX programmer. Before entering into the session, kindly like and subscribe our YouTube channel for more updates. So this is the second example for the counter concept in CX programmer. So let's read this. 3 counters in the bank can totally allow only 10% per day. It should restrict the 11th person to enter the bank counter. Okay, so each counter having one PB, push button to allow the person. So on the whole, only 10% can enter into the counter of the bank. There is a bank and they have a 3 queue. Okay, don't confuse this counter with that counter. So there is a 3. Let's rename that counter as queue. There is a 3 queue. Okay, so in the 3 queue, totally on the whole, only 10 persons can allowed. For example, the first queue may have 3%, second one may have 4%, and the third one should have 3%. Like that, on the whole, 10 should be there. Okay. So if the 11th person is trying to join me, it should restrict. We cannot allow that person to, do the bank. What purpose he came to the bank, he should not able to do, because he is the 11th person. Only 10% can allow per day. So at last what they have given, each counter is having one PB to allow the person. Alright. So let's see how to do that. So let's create a new program. So now how many inputs we are having? We are having 3 inputs. Okay. So 3 inputs for 3 counters. No, there are 3 queues and there should be a 3 push button. So I'm having the first counter push button. I'm naming that as Q1. Q1. Or we'll rename this as lion. Or I'm having this Q1 and this is Q2, and I have one more Q which is Q3. Okay, fine. So three Q are there and 3 push buttons are there. For example, if the first person is entering the second queue, means he will press one push button for the confirmation, so that his login or his entry is valid, like that. So for that only we are using the push button to to validate that the person who has entered the counters before the 10, before the 11th person, or valid entry. So for that I'm having 3 queues over here and I'm going to add a counter. So what is the purpose of counter in this example? How come I get to know how many persons has entered the queue? Okay, so for that only I want a reference. For that I am going to use a counter. Just a minute. So they have given us 10. Alright. So connect these instruction and counter. And we have one more input for the counter, no? So let's take one input for resetting the counter. We have to delete this. Alright, so we have a reset here. So let's go online. Okay, so the first person is entering. One push button is pressed. Okay, the second person is entering in the second queue, and that is also entry. The third person is entering. So each time, maybe the fourth person is also from the same queue. So next person, fifth person is also entering in the same queue. So now the second queue, one of the person is entering. Now the first queue is having one person. Now again the third queue is having one person. So now 8 people has already gone. Now only place for 2 person. Now there is only space for only one person. Yeah, that's done. So the counter is reached the limit. Correct. The counter is on. So now how I'm see if I'm entering, if someone is trying to enter, what will happen? See, the entry is allowing to counter. The counter has reached, but still the entry is going till the counter. Correct. So what we have to do? We have to restrict the entry to the counter. So for that, you can add a bit here to restrict the counter. So I'm adding the same counter bit as normally closed contact here. So what is the purpose of using like this? The entry will restricted here itself. So let's see now. See, the counter bit is on, no? So this is on. So this normally closed contact will become open now. Now if the person in the Q3 is trying to enter, it will not allow the person to enter. Anyhow, it will not disturb the counter, but still it even enter near the counter. It will not able to reach the counter. It is restricted. So with this counter bit, you can display that counter, the queue is filled or 10 people has already entered, login restricted, like that you can generate one more output here. Like a lamp indicator for counter full. That's, you can make it. Just type counter closed. Like that you can have a output. It's like an indication so that everyone is getting to know that there is no check-in hereafter. So it's done for today. Like that you can display the lamp. or a display, whatever it is. And so until you reset, what will happen? It will be on. So if you get reset, it will get reset. If you press that, it will get reset and you can start from beginning. See now the counter instruction normally closed contact become the previous. I mean how the normally closed contact, like that it happened now. Again you can enter the, people can enter into the counter now. It started counting. So this is how the example works. I hope you have understood this concept. I'll meet you in the next session with another interesting topic. Kindly like and subscribe our YouTube channel for more updates. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see one more example in counter. So, it's a car parking example. So, let's see about this. There is a gate to entry over here. Okay, and this is the parking, and this is the parking slot. And we have an entry gate and we have an entry sensor over here. So, the car is entering this way and this is the exit. And we have one more extra exit sensor over here. Alright, and this is the parking space. So car parking, each time a car enters, PLC automatically add it to total sum of the total car, other car found in the garage. Each car that comes out will automatically be taken off. Comes out in the sense it will, when it exit, automatically one value go off. When 10 car park, a signal will turn on signalizing that the garage is full and notifying other drivers not to enter because there is no space available. This is the perfect example for counter, right? So there is a occupancy of only 10 car. So we are every time in a car entering the parking slot, we are counting how many car has entered. Suppose if the parking is full, how come the driver who is entering can get to know? So we can use this kind of automation in this place, right? So that we can restrict the entry. We can allot them, you can go to the next slot, or you can there is no space, like that we can intimate them. Instead we can allow them and they come inside and there is no space and there is no way to go out. So it's a bit tough, right? So instead of this, you can intimate the driver in the entry gate itself. So let's see how to do this in CX Programmer. Alright, so I have an entry sensor here. So now I have to count up. In some case, I have to count down also. Correct? Because whenever the car is entering, I will be counting up, and car exiting, I will be counting down. So what I have to do? I have to use the same counter for up and down. For both, we have a counter which is called as reversible counter. So let's take that counter and give the name for the counter. And we have to set the value, like how many cars we can allow, like that. So counter is 0 and we can have 10 cars, right? They have given 10 cars in the example. This hash. Yeah. So I'm giving 10 here. Okay. So totally 10 cars can allow. But I hope you have remembered when we were discussing about this reversible counter. This will take 1 plus. So if you want to restrict the 11th car, means you have to give 11 here. So I'm editing this 10 as 11. So add horizontal line to join this up counter, because entry is the up counter and exit is the down counter, and you can move this to the second place and you can join them. This is the down counter, and we have a reset contact also. Done. So connect this. Alright, and they want some indication that counter is full, no? So I'm taking the counter's feedback. This is the counter feedback, and I'm giving that to some display or lamp, which will be telling that parking is full. Connect. That's it. Connected. Let's go online. Alright. Right. Now the first car is entering. So it started counting one car is inside. And the second one. And the third car is also entering now. So 3 cars are totally there. So entry sensor is like a pulse input. It will give only one pulse. Now 1 car is exiting. So now the total number of car inside the garage is 2. Okay. So now I am turning on the entry sensor for some more time. Look, there are 5 cars now. The 6th car is entering. 7th car. 8th. And 9th one. So now we have to allow the 10th one also. So 10 car, totally 10 cars over there. Alright. Now the 11th car is entering. So that time we are displaying. Wait, 11 car is entered. So now it's showing. So it have to cross the limit. So instead of 11 we have to give 10 over there. So that it will restrict the 11th car. Okay. So instead of giving the PV value as 11, we have to give 10. So let's change this value to 10. So instead of 11, give 10. So just go online. So the 10 has reached. The parking is full. So now if you exit, so it will start reducing. So now 9 cars are totally inside. So don't confuse with this value. Once the counter is full, it will turn it as 0. Okay, if you reduce the counter, it will start counting down. 10, 9, 8 like that it will go. So now 8 are there. If one more is entering, it will be 9. Now again 10. So 10 has entered. Okay. So 10 have to be allowed. That's what it is allowing. Now if the limit is crossed, it will turn on the lamp which is telling the parking is full. Alright. So it will not turn on exactly at 10. Okay. If you see the normal counter, it will turn on when that particular output, the particular PV has reached. But our up-down counter will be exceeding. One exceeding means it will give the output. Alright. So this is the perfect example to understand the up-down counter, and this is the last example for counter instruction in CX programmer. So I'll meet you all in the next session with another interesting topic. So before winding up the session, kindly like and subscribe our YouTube channel for more updates. Thank you.
Hello everyone, welcome to Automation Community. In this session, we are going to see about arithmetic operation in Omron PLC. Before entering into the topic, kindly like and subscribe our YouTube channel for more videos and updates. So let's start the topic. So arithmetic is one of the important set of instruction in all PLC program, because whenever you want to process some values, obviously we are in need of some instructions like addition, subtraction, multiplication and all, right? So let's see how to get this instruction and what and all addressing we have to use it for that. So let's take a new PLC instruction. Go to details, go to find instruction. So in this you can see arithmetic operation here. All right. So in this arithmetic operation, you can make use of this plus. So let's see about plus. See, you can see there are so many plus over here. So this is the basic one. This plus 400 is the basic one. Signed binary add without carry. So this is BCD add with the carry, without carry. And this is for double integer, for 32-bit addition. So like that, you have multiple options in Omron PLC. In this, instruction set, you can see there are so many options for addition, but this is the basic one, right? So let's go for it. Just choose that. And after that, it is asking for operand. If you see here, there are operand 1 of 3. So it requires 3 operands. All right. So what may be the 3 operands? One may be the first one you want to add. The second one is the another one you want to add. And the third one is the result where we are going to store it. All right. So since it is a 16-bit addition, I'm going to, you can see, you can give the word address here. So I'm going to give the 16-bit word address D0. Okay. So since I have entered, it came to this place. So better we'll delete and add it one more time. So I'm going to put plus. That's it. That's enough. So we are going to add the numbers. So the first number I'm going to store it in D0, which is a 16-bit address, and I'm going to add one more address, which is D1. So this is also another 16-bit address. So this D0 plus D1 I'm going to add. All right. So where I'm going to put the result? So for that I'm going to get one more address, which is D2. Okay. So just click OK. And you can give the comment for what is this D0 and for D1, and you can give D2 as result. LT. Alright. So you got the instruction for addition, and you can write one condition over here in the front. I'm going to give 0.0. So just connect the run. Okay. So just go for simulation and work online simulator. So it's ready to simulate. And if you see the default value over
here for D0 is 0 and D1 is 0 and D2 is 0. So I'm going to give the integer value and you can see the range here. Okay, since it is a, okay, I think before I have mentioned that as a word, this is actually an integer data type. D0 is a integer data type and you can see the range over here. Okay, so I'm just going to give some value. Let's take a 200. All right, and for D1 you give some other value, maybe another 200. So there are two values over here, so D0 and D1. So once the condition is true, it is going to add D0 and D1 and put the result in D2. Now the result is 0 in D2. So let's turn on the contact. I'm going to force it. So once I force it, it will do the operation and put the result in D2. All right. So if you change now, what will happen? Let's see. Instead of 200, I'm putting 300. So immediately it is adding. Okay, because the condition is true. Since the condition is true, you can see the live result over here. Suppose you are making this 0.02 off now. Make it off. And now change the value of D0. Let's see, one more 300 here. So now if you see, the result is not changed because the condition of the rung is false. So let's make the condition true and see the result 600. Okay. So that's it about the addition instruction. So the same thing we can do the subtraction also. So let's see how to do that. So let's delete this instruction. I'm going to add the new PLC instruction here and just put minus symbol. So that's it for subtraction, and you can add the same address or different address. As of now, I'm just putting the same address. All right. So let's go online and see. Since I have used the same address of for the addition I have used, the same address I have used. So that's what the values are still there. 300, 300. And the result is, for the previous D2 value was 600 and it remains the same. Suppose if you make the condition on, so this D0 minus D1 will happen and it will store it in a result D2. So 300 minus 300 is 0. All right. So this is how subtraction will work. So this is the integer value. So what if you are giving some negative value here? Let's see, minus 400. All right. This is plus 300. So what is minus 400 minus 300? So let's see that. And you see the result is minus 700. So minus and minus get plus, and the minus symbol will come. So 400 plus 300 is 700. Since it is a minus and it is taking the minus symbol, so it is minus 700. Since it is an integer value, you can give both positive and negative. If it is a word, you cannot give the negative address, negative value. All right. So this is arithmetic subtraction and arithmetic addition we have seen in this session. All right. So I'll meet you in the next session with multiplication and division. So if you are not subscribed to our channel, kindly like and subscribe so that you will get the more updates from automation community. Thank you so much.
Hello everyone, welcome to Automation Community. In this session, we are going to see about Arithmetic Operation Part 2. So before entering into the topic, kindly like and subscribe our YouTube channel for more videos and updates. So in the previous session, we have seen addition and subtraction. And in this session, we are going to see about multiplication and division. So let's see about the instruction. So let's get a new PLC instruction, and for multiplication we are having this symbol. All right, so same like our addition and subtraction, I'm going to give two variants and one output. All right, so this is a 16-bit, all three are 16-bit. So just give OK, and just give one condition over here. Connect it. So D0 multiplication into D1 and is equal to D2. The result will be storing in D2. So let's go for the simulation. So now initially the value will be 0, 0. So the answer will be 0. And moreover, the condition is not true yet. So suppose if you are making the condition true, you can see 0, 0, 0. Right? So now I'm just making this to some value. Just tap on it and you can give some value. Let's say 10. So now 10 into 0 is 0, correct? So now change the value of this, give one more 10 here. And now if you see, the value is 100 now, right? So let's give this is minus 10. So the answer is minus 100. Okay, so this is a live update. This is multiplication. So in the same way, we'll do the division also. So let's take the same 0.0. Let's take that here and add one more new instruction. That's for division. So for division, the symbol is this one, slash, front slash. Okay. So now I'll give a different set of address, D3, D4 and D5. So just go for the rung connection. Alright. So just go for the simulation. Now all the four instruction like the addition, subtraction, multiplication, division, all three are for integers. Okay, this is for 16-bit addition and subtraction and multiplication and division. All right. So now if you see, okay, so there is one concept over here, and this becomes a 32-bit. Okay, so if you see the D over here, no, that is nothing but a double. So whenever you are doing a multiplication, the result may be, it may cross 3267, the highest value, this value 32767. So for that they have made that as a double integer. Double integer means that will be the 32-bit. So that's what you can see the D here. And since I have used D3 here, you can see some, instead of 0, there is some value over here. This is minus 1. That means what? As I have already told you in the previous session and even in the beginning of this session, D0 is nothing but a 16-bit register. Correct? D1 is a 16-bit register. When you want a 32-bit, what you have to do? You have to combine D0 and D1. Alright. So that's what, see, if D2 is a 32-bit register, D2 and D3 both are combined, right? That's what you can see some default value in the D3. Okay. So it should be a 0. But since I have used D2 as a 32-bit here, I'm having values over here. So what I have to do, I have to change the address here. So what I'm going to do is make this as D4
D5 and this going to be a D6. So let's go for the simulation. So now the result word is word only, 16-bit only. This D6 is the 16-bit only. So there is no D over here. Look at this. So let's turn on the input. So give some value 100 and D5 is 10. So that 100 by 10 is 10. You can see the quotient here. This is the quotient. Alright. So 10 by 100 by 10 is plus 10. This is the quotient value it will show. Okay. So what if you want a decimal, you want to, deal with the decimal arithmetic operation, not decimal, sorry, it's a floating point, real arithmetic operation. So far we have seen that integer, right? So you can give this much value and this much value and, there are some range. So what if you want to deal with the real floating point? For example, here 10 by 10 is, 100 by 10 is 10. Suppose you give 20 here and here this is a 3. So what is 20 by 3? It may be 6 point something, right? So it is a, fraction. But now if you see the result is 6. It is giving the quotient, correct? It is a quotient value. So you want the value like 6.666 like that means you have to use a different set of instruction. This is for integers for 16-bit. So if you want to use it for the floating point means you have to use a different set of integer. So I'll show you that also. So let's make the same input here. Go for D10. Go for find instruction and you can see there is a option for floating point. See, there is a floating point and here you can see division, multiplication, addition and subtraction for floating point numbers. So now I'll take division and I'm going to give D4, D5 and D6. Same value I'm giving, okay. Okay, since it is a 32-bit, I have to give like, I'll take some other value. So I'm giving D10. So D10 and D11 is for the first one. So I have to give here as a D12 and 12 and 13 for this and I'm giving D14. Alright, so it I have taken now since it is a 32-bit. So previously I have told no. So let's give the value as 20 here and it will be taking the rest 20.00 since it is a floating point instruction. It's taking like that and you can see the range here. How much range you can give. See? So 20 by 3. Now you can see the answer will not be only 6 but you will get the exact decimal value. Look at this 6.66666 and it is round off to 7. Alright. So this is the floating point instruction for division. The same thing if you want to multiply two real numbers, two floating point means you can use multiplication instruction from floating point, the particular instruction you have to choose. Alright. So this is an arithmetic operation instruction in Omron PLC. I hope you have understood the concept. Kindly like and subscribe our YouTube channel for more updates. Thank you.
Hello everyone, welcome to Automation Community. In this session, we are going to see about instruction for comparison. Whenever we want to compare two values, we are using this comparator instructions. Kindly like and subscribe our YouTube channel for more updates and videos. So without any further delay, let's get into the topic. So get an instruction help, go to details, find instruction, and there is a group called data compare. So in that you have multiple instructions. There are more instructions. Look at this. This is less than, and the same symbol you can see this is calendar less than, and one more less than is there, which is for floating point. This is for long less than. This is a data type. Okay, for different data type we have a instruction. So the same less than instruction is there for word and double integers, floating point numbers, even for calendar dates also we have. Alright, so let's see about three instructions today. So this is less than, and we have greater than and less than. See, equal, this is less than, and we are going to see about equal and greater than. So these three instructions we'll see in this session. So let's take equal to first. So here you have to give the operand, which two value you want to compare, that one you have to give. So I'm going to use D0, and you have to give one more value to compare. So one is D0 and another one is D1. So let's take this and take one input, which is let it be a switch. Alright, so connect these two. Just connect. So it is connected, but still you can see there is an error here. Just a minute. Yeah, see, this equal is having red color. What does that mean? It is having a error. So how to find out what error and where exactly it is? So let's do the compile. Let's compile it once. So if you compile, you can able to see what error it is. See, function equal is positioned incorrectly at rung 0. So what is this position incorrectly? That means it is not in the right place. So whenever you are using an instruction, you have to know where to place it. Alright. So there are two types of instruction. One is input instruction and output instruction. What is the difference between this input and output instruction? Means where exactly you are going to place in the ladder logic. See, timer and counters are output instruction. We will be putting over here. Even addition and math operations also a output instruction. But comparator is a input instruction. So just cut it and paste it in between, and have one output here. Let's say 100.0, which is let it be as Q0. Alright, see, now the error is gone. Look at this. This is the input instruction, because from this we have to get the result of this block. So that's what it is, input instruction. If timer and counters are, we can able to make use of the address of counter and timer in the remaining rung. You can make use of it, right? For example, in our previous session, if you see, we have used the timer in the output, in the right hand side of the run, and to make use of the timer's address, we will be using one contact and putting the timer address. Alright, so for comparator instruction there is no option like that. That's what it is, a input instruction. So through this block itself we have to get the output. Okay, So let's go for the simulation. So how to make this comparison? What equal what? So whenever you are putting the first value of the address, right, first address, that have to be at the right, left side. So now D0 at left and D1 at right, and you're equal to, the operator have to be in between. So D0 equal to D1. This is the formula. How to frame the formula? D0 have to be left, D1 have to be right. I mean the first address have to be left, second address have to be right, and in between the operator. Now let's see, D0 is also 0, D1 is also 0. Just turn on the input condition and your output is on, because D0 equals D1, 0 equal to 0. That's what it is on. Okay. Now change the value to something. Now the output is off because 23 is not equal to 0. So whenever you want to compare two values, that may be some sensor values, for example in a tank water level control system, so you can give the set point as tank expected height, expected level. Once the level transmitter is giving that value, you can able to turn off the water, the flow you can control, or you can cut off the flow. I mean you can turn off the motor. So like that you can make the application using this comparator instruction. So turn off this, and after that if you change, see, make this to 23, you will not get the output because your input condition is false, the rung is false. So make the rung true, it will on. Alright. So let's see the next instruction, which is less than. So let's put the same input here and take this, go for details, find instruction, data compare, and there is let's take this less than, first one, same value I am giving, D0 type D0 space D1, that's it. Connect one more output here, which is 100.01, which is Q1, that's it. Connect. Now it's ready to run. So now we are going to compare less than. So D0 less than D1 means turn on the output, that's it. Now turn on this. This is on, the first condition is on because 23 is equal to 23, but 23 is not, it's not less than 23, it's equal, right? So that's what this is not on. So I'm going to reduce this D1's value, tap on that, make it to 22. Now if you see, the second instruction becomes high, so the output is true. So 22 is less than 23, it's true, so the rung is true. So like this we can make the next instruction also, which is greater than. Greater than, and here also I'm going to give the same address, D1, we'll give the same input, output should be Q0.2, sorry, M just 100.02, which is Q2, different output. Now connect the run. Alright, go for simulation. So these three are the very simple instruction, less than, greater than, and equal. I'm going to turn on the input. Now D0 is having 22, right? So 22 is less than 23. So the less than instruction is giving the positive output. So 22 is not equal to 23. I mean, not equal to 23. That's what the first instruction is off. And the last one is off because 22 is not greater than 23. So now change the value of 23 to 24. The last instruction is on because that is greater than 24 is greater than 23. So it is true. I hope you are understanding the concept. Now I am making again back to 23, though, so the first instruction is on. So try to give the some floating point value. It will not accept because this instruction is completely dedicated for the integers and word. Okay, invalid value entered. So just delete that. So the last instruction is on because 89 is greater than 23. Simple, right? So I hope you understand these 3 instructions. I'll meet you in the next session with another 3 instruction in comparison instruction list in Omron PLC. So kindly like and subscribe our YouTube channel. I'll meet you in the next session. Thank you. Hello everyone, welcome to Automation Community. So in this session we are going to see about comparator instruction in Omron PLC. Kindly like and subscribe our YouTube channel for more updates and videos. So without any further delay, let's enter into the topic. So in the previous session we have seen 3 instructions in the comparator. So one is equal and the another 2 is less than and greater than. So in this we are going to see about remaining 3 which are not equal to, greater than or equal, less than or equal. So this is less than or equal, and we have greater than or equal, and there is not equal also, which is this one, 305. So this is the instruction number. So let's see about 305 first. Not equal. So I am giving the address of the particular number, the first number. Okay. So we should not press enter at this stage. It should be one more number is there, no? So just type that number also, that address also, and then enter. Okay. So put it in the input side. Just cut it and paste it somewhere between this input, input condition and this one. So just connect this. Take one output. Connect the rung. So that's it. Go for the simulation. Now D0 at left side and D0 at right side. I mean D0 at left side and D1 at right side. In between you have to put the operator, not equal. Correct? So let's see, 0 not equal to 0. Is it true? No, right? So that's what it is off. So let's make the value to some other. Now the output is on because 1 is not equal to 0. Correct? So let's make this also to 1. Immediately this will go off. Okay. So this is not equal to instruction. So like that we have greater than and less than. So let's see that also. So I'm going to find out, this is less than or equal. So give D0, D0 and D1, that's it, and then enter. Okay, so connect one of the input here, 0.00, and connect one more output, 100.01. So connect these two instruction, that's it, and we are having a error here. So let's see what is that. So I think instead of D0 there is O, DO. So go to this and edit D0, D1, that's it. Okay, so go for the simulation. So now D0 less than or equal to D1, correct na? So let's turn on this. Now see, your output is on because D0, 1, that is less than or equal to 1. So there are two options, it should be less than or it should be equal to. So it is satisfying in the second category, equal to, that's what your output is on. Okay, so now change the value to some other value, and there should be a limit. See, the value should be 0 to 65535. So if you give more, it will not accept if it is more than that. So now both the instructions are getting passed because it is not equal to, correct, one is not equal to 7687. So the first output is on. Why the second output is on? Because 1 less than or equal to 7867, because 1 is less than 7867, so output is on. Understand? Understand the difference. So this is not equal to and this is less than or equal to. So it is satisfying in the less than category. So that's it about these two instructions, and we have one more for this session, which is greater than or equal. This is less than, and we have here it is 325, greater than or equal to. So give the same address. Why I am giving the same addresses? For better understanding, so that we can compare all three. So connect one new output, and just connect, take one more input here and just giving the same. Instead of turning on all three inputs separately, I am adding the same input in all the three runs. So go for the simulation. Correct. So now turn on the input. What and all instruction, what and all output will on? First two are on because this is E not equal and this is less than. So 0, 1, this D0 is not greater than 7867. I mean 7687. So your output is off. Just to change the value to 9000. Now your output is on. Your third output is on, and your first output is on because this is not equal, this is greater than. So let's take this is also to 9000. Both the instruction are on because there is a equal operator here. So like this you can play with this instruction in the application. So I hope you have understand the concept. I will meet you in the next session with another interesting topic. Kindly like and subscribe our channel for more updates and videos. Thank you. Hello everyone, welcome to Automation Community. In this session we are going to see about BCMP instruction in Omron PLC. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates and videos. So what is this BCMP? So it comes under the comparator instruction. Okay, so BCMP is block compare. So before we have seen instructions like comparing two values, right, that may be a greater than or less than, like that. Now we are going to compare two blocks, two complete 16-bit we are going to compare. Okay, so I'm going to get help from the manual. So this is the instruction block for BCMP, block compare. Okay, so in this we have three things. First one is source data. So which data you want to compare, that data you have to put it in source. The second one is first word of block. So this is the block we are going to take as a reference, and the result have to be stored in R, that is result word. So the first one is source data. This is first block of word, the first word of block, and the last one is result word. So there are three content in block compare instruction. Let's see more about it. Now yes is the source data, as I have told you already. This is the source data. This is the one we are going to compare with B. B is what? B is the block. See, the first block, the first word of block. So the B is having some ranges of values. So I'll explain you in the example in a better way. And R, which is the result storage place. So now what we are going to do? For example, you are going to have one value in the source and you are going to have some value in B. Okay. So now this B, what it will do? It will compare the value which is in S within the range B and B plus 1. What is B plus 1? For example, if I am declaring B as 200, 200 and 201, D200 and D201. So the value which is in source is in range of B and B plus 1. Then it will return 1, else it will be 0. Okay. So now let's imagine B is 200. The address I am telling, okay, D200, and B plus 1, which is 201, is having some value. Okay, so D200 is carrying some value and D201 is having some value. If our source value is within this range, then it will return 1, else it will be 0. Like that, you have 16 comparators here. See, from B to B plus 30. For example, if you are taking B as 200, D200, then it will be 230, D230 and do D231. Okay, so if that is within the range, our source data is within this range, then it will returns 1 or 0. So this is the 16-bit result. Okay, so let's see this. Look, here the values are given in hexadecimal. Okay, so see here they are having some value in D100, that is the source data. So this is our source data. 03A0 is the source data, and D200 is the block. So in this block we are going to split that into 16. Okay, look at this, D200, D201. So we have to check whether this 03A0 is in the range of the value which is in D200 and the value which is in D201. Okay, so there may be some application like this complete D200 from D231 is having some values, and you want to compare or you want to find out whether the particular source data is in the range of any one of these blocks. So in that case you can make use of this block. Look at this, 03A0. So it's not in this range.
Okay, so it is returning 0. For example, see, look at this, the third bit is having 1. That means what? This 03A0 is in the range of 0000 to 0400. That's what it is returning 1. And look here also, it's also same 03A0 and 0400. It is within the range. The number is starting with this number itself. So it is returning 1. So now we'll see one example in the PLC program. Okay. So before that, this block works with the hexadecimal values. So I have put some hexadecimal values here. For example, if I put 64 and the decimal value is 100. If it is 96, it will be 150. Okay. So just these values for our reference, which we can make use of it in the example. So let's see that. Now I am going to get this instruction first. Compare VCMP, this one, unsigned block compare. So go with this. It's asking for the address. So I'm going to give the same address what we have seen in the manual. D100 is the source, D200 is the first block of the address, and this is the result data. That's it. So we have added that. Okay. So now add one input condition 0.00 and connect this. It's connected. All right. So now let's take the monitor window. It's not output. It's a watch window. Okay. So I'm going to add this address D100. This is D200. This is D300. Okay. So now let's go for the simulation. See, here you can see. Now just I am giving some value. Okay. So let's take the example of this one. Let's give the value 100. Understand? Let's give the value 100. So it will be taking that as 64. So I'm giving the source. See, I'm in source data I'm giving that as 100. If you give us a decimal, it will take us a hexa. Okay, 64 is taken by D100. Now give some value for D200. So what I'm going to give? I'm going to give 200 as 50. Okay. So for 50 it is 32. So now what it will be doing? It will be first comparing D200 and D201. So now in our program we don't define any value in D201. Okay. So now we have just put the value in D200. So we'll do one thing. We'll put some value in D201 also. So what I'll do, I'll take one addition instruction. I am giving the values D201, okay, and D202 and D203. It will be storing in that result, okay. So now that's it. Addition is just addition, so that we can move the value. That's what I have taken the addition instruction. To move the value, I have used this. So now watch clearly. Now our source data is having the value of 100 and D200 is having 50. Now what I'll do, D201 I'm having that as 150. Okay, I'm giving the value as 150. And this one, D202, I'm giving that as 180. Let it be as 180. Alright. So once I will turn on, what will happen? These two will get addition and here we will get the result. In the meantime, what this block compare will do? First thing, let's see this. We are having 100 here, okay. So D200 is having 150, I think. I have given 150. D200 is having 50. D201 is having 150. See, this is 50, this is 150. So our 100 is within the range of 50 and 150, correct? So it will return 1 here, right? Now what value I have given to 202? So for 202 I have given 180. Okay. What will be in 203? 150 plus 180 is 200. It's 210. No, not 200, 230 and it will be 330, right? So is that 100 is in the range of 180 and 230? No, right? So it will be returning 0. So let's watch that. I'm going to force this. Yeah. So look at this. This is the answer which is having 1 here. That means what? This 100 is within the range of 50 and 150. So every 16 bit it will compare. So 201, 200. If it is in range, it will return 1. Else it will be written 0. Like that we have this answer. Alright. So I'll do one more thing. Now let's move some value for 204. Okay. So what I'll do, I'll take the same bit and I'll do the subtraction of this minus D203 D204 D205. So now D203 is having some 230 value, I'm right. I'm going to minus the 230 minus some 200, like that will do. $180 will minus. I'm turning on this. So now it is 150. So 100 is within the range of 203 and 180. 203. Okay, let's compare 202 and 203. What is in 202?
What is in 202? It is 180. Okay, so 180, 330. Is that 180 and 330, 100 is within the range? No, right? That's what it is returning 0 here. See the second bit. For example, if I change the value of our 100, instead of 100, I'll give 190 and see this bit is on. Can you able to see? This bit is on. That means what? This 190 is within the range of 180 and 330. That's what this bit is on. So like that it will compare each and every two 16-bit register. Here it will compare this value between this value and this value. If it is present, if the source data is present, it will return 0. Like that it will compare and it will give the 16-bit answer. So it will be starting like this is the least significant bit. This is 16th bit. The last one is the 16th bit. So if you see, this is the 16th bit, which is 0. Okay. So like that you can compare. Now I can make this to some other value. Let's see. Now I am giving the value of 240. So 240 is within the range of 200 to 300. That's what this is on. What value we have given in 200? It is 50, right? So 50 to 200 and 201. So this is 50, this is 150. Our value is this is 200, right? Yeah. Okay, this is 200. So 50 to 150 it is not, so this is 0. So the 200 take 200. This is between 180 and 330. That's what this is on. Okay. So now change the value of the third one also will change. Now 200 we have given, no? So we will checking this value to 200. So 330, 200. So we have to check whether that the value which is in source is between these two values. If it is there, it will be turning on. Okay. So the one thing what we have to understand is the value, the address what we have given here, that will be the first 16-bit register. So 200, 201. Okay. Next 202, 203. Then 204, 205. Between 300, this one. 330, yeah, this one here it is 204, no? So this is 200, this is plus 130. If it is not in the range, it will return 0, else it will give some value. So like that you can compare the block and get the result in the new register. So all 16 comparison are done and put the result like this. See, all 16 are done and the result is displayed in the result register. So this is block compare. So once you practice the example, you can understand it in a better way. So here the values are shown as the hexa. Okay. So now we'll give the value as 10. Okay, I'm giving 10. And 200 will be 5. Let's see, 203, 201. So 200 and 201 will get compared, no? So this value is 10. Okay, 200 is 5. So I'm giving this as 15. Look what is happening. Nothing is happening because the condition is false. I'm making the condition to true so that the first bit gets on. Because 5 is in the range of 10 is in the range of 5 to 15. Understand? So now what I'll do,
Now the next comparison will be between 202 and 203. So 5 is in the range of 180 and 195? No, right? That's what it is, 0. Now I will change the value of 202 to 3. Now see, 3. 5 is in the range of 3 to 18, am I right? That's what the second bit is on. Okay, so this is block compare. So for getting those values, I am using plus and minus block to feed this value. Okay, since we have not seen the move instruction, I cannot use the move instruction here. In the later classes, we will see that instruction. So I have taken the help from addition block to see the value of this. Okay, 204, 203. The thing is, first what we have to compare, 200 to 101, then 202, 203, one by one, 2 register at a time, from 200 to 231. So there are 16 in this line and 16 in this line. So we will be getting the result in another 16 bit. So I hope you have understand this block compare instruction. Just practice it in a software for understanding the instruction well. So thank you so much. Kindly like and subscribe our channel for more videos. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about zonal comparison in Omron PLC. So before entering into the topic, kindly like and subscribe our channel for more videos. So this is the last instruction we are going to see in comparator. So just see that you can see in data compare there is a zonal compare here, ZCP, area range compare, or else it's also called as area range compare or zonal compare. Okay, just take this and just click OK. So now let's see, this is also an output instruction. Okay, so block compare is also the output instruction and this is also the output instruction. So this is having three variables. One is compare word. This is like a source. Which one you want to compare, that value you have to give in the compare word. And there is lower limit of range and another one is upper limit of range. So lower limit of range is like what is the minimum value you want to compare. For example, if you want to maintain the temperature between 90 and 100. So you can give the lower value as 90 and upper value as 100. You have to give the exact temperature value in the compare word address. Okay. So I'll explain you with this. Take one input condition, connect the rung. Now need to give the value for all these three. So what I am going to do, I want to put that as a variable. So I am giving the variable address D0, D1 and D2. All are 16 bit. Alright. So it's connected. Okay. So just go online. So all are having 0 now. So now what I am going to do, let's imagine the temperature transmitter value is 70. Okay. Now what is the minimum range you want? 90. And what is the maximum temperature you want to maintain, which is 100. Okay. Now the value is 70 and the minimum 90, maximum 100. Now turn on your condition. So now this zonal is comparing and giving the output. So how to get the output from zonal comparator? So for that we can make use of some system contacts. So just go for normal contact and drop down this box, combo box. You can see less than, see, this is PLT, that means less than, see. So this block output can be used as a contact here. So this is a system block, system contact, okay. This is not having any address and all. Since we have used this block before, it will be comparing the previous rung comparison it will do. Okay, this is a generalized one, it's not having any address. So what this instruction will do, it will compare the previous rung, comparison result and show that here. That's it. So let's put one address here, 100.0. I'm giving that as low temperature, okay. So just go for online. So yes, the temperature is not in range. If it is below means we will be getting this output. So just turn on now. Can you able to see your output is on low temperature? Imagine this is a LED, which LED is on. Why? Because the current temperature is 70, but the required is 90 to 100. So it is a low temperature only, no, it is below 90, that's why it is on. Let's make this to 95. So this is within the range. See, your low temp is off. So to see this particular output, now it is in a current, correct temperature, right? How to see that? And what if it is exceeding 100? It will be the high temperature. For that also we want a LED indication, right? So how to get that means, same like this we can get the block, instruction for, or the contact for, equal and greater than. So we'll add the same. You can see equal, P equal. Take this and take one more contact which is for P greater than, PGT. Click OK and take two more outputs, 100.01 which is temperature, OK, and one more output here for high temperature, right, 100.02 which is high temp. That's it. So let's go for the simulation. So now what is the value we have given here, which is 120, right? So it should be the high temperature. So we have to turn on the last input, see, high temp. Okay, the LED, this particular output is on, so you have to see that it is on. Now put that back to 95. So this is within range. So that time the high temperature LED is off and temperature OK is on now. Correct now? So let's turn off this to 56, turn down, make the temperature down. So which is below 90. So it is comparing the range between 90 to 100. If it is between 90 to 100, it is equal. For example, make 90, then it will be equal. Okay. If it is 100, that is also equal. Correct. If you make this to 101, then that will be high. Even 1 is also high. If it is 89, then it will be low. Understand? What if I give the point value? It will not accept because it is a 16-bit. Alright. So that's it about the zonal comparator. So along with this, we have one more instruction which is for the 32-bit. So not only for this zonal, we have for, see, if you go for the data compare, no, you can see this is for floating point. This is for this you can give the floating point input. So like that you have for 32-bit you have. This is long area range compare. Okay. So for this you can give the decimal value. You can practice this. So what all the instruction we have seen in our classes are for integers and word. So if you want to use the floating point comparison means you have to put the
respective block. Alright. So I hope you have understand the concept. I'll meet you in the next session with another interesting topic. Thank you. Hello everyone, welcome to Automation Community. In this session, we are going to see about move bit instruction in Omron. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates and videos. So in the previous session, we have seen move instruction which will be moving one data which is from source to destination. It will move the value from source and place it in the destination, right? So, but here we have a bit movement. So, here we are having three addresses. One is source, another one is destination, another one is control. So, this C is the control word which will be telling which bit you want to move from source and where you want to put that in the destination. Those details will be given by the control word. So, let's see that. So, here imagine C is the control word, no? Here you are having M and N. So, N will be the specified bit in source and M will be the specified bit in destination. You are going to move this nth bit and putting that in the mth bit. So, with more clearance, you can see here 0C, 05. Alright. So, 05 from source is going to 12th bit of destination. Alright. See that in the example. So, I am adding one new project. Go for OK. So, let's add one normally open contact and move bit which is going to be the move B and the source address, the control word and the destination address. Alright. So, go for connection. Go for work online simulator. So, it's went online. So, before turning on 0.0, I'll try to give the value to all the, for source and destination and what is the control word. Those details we want to give, no. So, I'm making this as a hexa and then source I'm giving all 4F. So, destination let's take A731 and the first will be the hash since it is a hexadecimal. A731 I'm giving, okay. So, in the control word I'm giving the same data 0C, 05. Before that add hexadecimal symbol, alright. So, the 5th bit of source word is going to move to the 12th bit. C means 12, right? So, let's turn on this. You can see the change in data, change in destination data. So, to understand this better, let's take a help from the binary form of all those three datas. So, source I am having 4F, no? So, what is the binary form of that? All 1, 1, 1, 1, 1. It will be completely all 16 bits are 1. Alright. So, destination is having A741. So, there I am having a 3, 1 I think. So, let's change this to B731. Okay. 41. Okay. A741. How it is changed to B741? Let's see. What is the 5th bit of source? This one, no? Let's make that 0, 1, 2, 3, 4. Sorry, this is 5. Not this one. This is the 5th bit, right? So let's change the color of that. So where that bit is going to go? It will be the 12th bit. So this is gonna be the 12th bit. This is 7, 8, 9, 10, 11, 12. This is going to be your 12th bit. So this one is going to the 12th bit. So what will be the new value then? 1 0 1 1 0 1 1 1 0 1 0 0 0 0 0 1. Remaining and all will be same, alright. So what is 1 0 1 0? It is nothing but 13th bit. So it will be B. The remaining and all is same. So that's what we got the destination value is B741. Correct. I hope you have understand this. Alright. So now let's see. We'll change the first bit. I'll change that to some other color. First bit is going to first bit. Imagine like that. So what will be the new value now? 1 0 1 1 0 1 1 1 0 1 0 0 0 0 1 1. So what will be this? Everything and all will be same, right? B7 4 and this going to be 3. B7 4 3. So let's check out here. So what I have to give here is 0 1 0 1. Can you see the address is the destination data has changed B743. So it is B743. Alright. So here the control word was C is 0 1 0 1. So the first bit is moved to the first bit. That's it. Alright. So I hope you have understand this move bit instruction. I'll meet you in the next session with another interesting topic. Kindly like and subscribe our YouTube channel for more updates and videos. Thank you.